Hello, good morning, all parents and students. So, welcome to my stretchers session on the Jumpstart Bootcamp and Jumpstart Workshop, actually, for our students who are doing Secondary 1 Mathematics next year. For those of you here, actually, you all have just finished the PSLE this year, right? And you all would also have just gone through the Secondary 1 posting exercise. Actually, the results will be out pretty shortly, right? So, you'll be knowing your secondary schools and all as well. But definitely just putting that aside, like what we always say, just remember PSLE is just one of many milestones along the way, right? And just take it from here, right? Regardless of whatever the results has been, right? Build upon that, right? As you go into secondary school, it's a new chapter. Hence, we also have these, jumpstart sessions to really help all our students to really prepare for the new year ahead, to give you all a head start in terms of, what are the new things that you're covering, what are some of the key topics, key units and different subjects actually that you'll be looking at as well. So perhaps just to introduce ourselves before we start proper today, I'm teacher Wei Lun here. And together with me, we have teacher Quy Lim and teacher Chiang Heng, right? So we teach primary and secondary mathematics here at MindStretcher. And today we will be actually covering and giving you a kind of introduction to some of the very key few topics and very core topics, I would say, that you will face as you go into secondary 1, next year. Very shortly, actually, just a couple of weeks more, right? And actually, these two topics that we are focusing on is really in terms of number systems and also in terms of algebra. And for many of you here, you realize, this is something that doesn't sound very new to you, right? And that's the good thing, because you will realize that a lot of things that you all do at secondary are pretty much linked actually to what you all actually covered at primary level. So even things like, you all have started on algebra, right, at primary 6, and you all also have been doing whole numbers for quite a number of years already. So it's really building upon that. That's what we call in math as a spiral concept. That means we are building upon that. We are doing things that are more complicated, but still linked to things that you have learned before, right? So today what we'll do is we'll give you a kind of taster right into this. And many of you here, I think you should already have the material. So if you don't have that we have shared, you can click on the link that our colleague has provided in the chat to access the material from there. And during this workshop, then we can also work through together, right? And anytime, just to keep it interactive also, anytime that you all have any questions, also feel free to post it in the chat and we'll be happy to take it from there as well, right? And and as you know, I think some of you are very eager, so you may be practicing the questions and coming out with the answers. So as you all do that, right? So what you all can do is I can point you all to the Q&A. You all can see down there in the Q&A button, right? You can click on that. You can post your answers there when we go through the question. Then we can click through from there as well. Actually, maybe just to put it the other way, sorry, just change that a bit. Yeah, if you have answers, what you can do is you can use the chat function. So all of you can see besides the participants button, there's a chat function, right? So later as we go through the questions, you can click on the chat function. And then from there, you can put in your answers. Then our teachers will also go through and check the answers for you. Try not to use the Q&A one instead. So let me just change that a bit. The Q&A one, let's reserve that for any comments, any questions that anybody has. That means if you all have any questions, any clarifications, you can put that in Q&A, and then it'll be easier for our teachers to see also, and then we can help with any clarifications from there. Okay, so again, now just reiterate, if you all want to type your answers for us to check your answer, you can put it inside the chat function, right? And any questions that you all have, then you all can put inside the Q&A. Okay, can? Yeah, so with that, right, so what we're going to do is we're going to kickstart today's session so everybody can have your worksheet in front of you if you have printed it out. If not, no worries, you can just put it on your laptop or your iPad and all that, and you can access from there too. Okay, so I'm going to hand over to teacher Chiang Heng to kickstart for today's session. Okay, so teacher Chiang Heng.
Okay, thank you, Teacher Willen. Yes. Okay, so for today's session, as mentioned by Teacher Willen, we are going to cover both numbers and algebras, right? So for numbers, correct? I believe you guys already very familiar with numbers, right? Because maths is all about numbers, right? So let me share my screen. Okay, so we are going to cover the first part here, set 1A here. Okay, so if you turn to the first page, okay, you'll be able to see there's a big diagram here. Okay, So some of the terms here, okay, you might find it unfamiliar, okay, but some of the terms I believe that you guys have already been seeing all this number all the while in your primary schools. Okay, so for a start, okay, I just want to check with you guys. Okay, can you all still remember what are the things that you all have learned in primary school, right? Like things like what? You all know numbers like 1, 2, 3, 4, 5, right? Okay, so all these numbers, do you all know that they actually have a name to this group of numbers, right? And what kind of numbers that do you all learn besides this, what we call the whole numbers here? 1, 2, 3, 4, 5, they are called whole numbers. So what type of other numbers do you learn in your primary school? Okay, you do see there are some numbers that you should be familiar with, right? Okay, so you see this number here, we have 5 over 6. What is this number called? 5 over 6. You see this number here, right? 5 over 6. So what is it called? Ah, yes, fractions, correct? And how about numbers like this? 0.34. What are this? What are these numbers? Yeah, you can type your answer in the chat. Okay, as mentioned, now we want to make sure that this section is interactive as much as possible. So what is decimals? Ah, correct. Okay, so you guys have learned things like whole numbers, fractions, and decimals, right? In your primary school. Okay, so now we are going to introduce to you guys more numbers. But I believe you guys have already seen numbers like these two in your daily life. Numbers like -1, numbers like -29, right? Okay, so we didn't learn this in primary school, but I believe you guys had already seen these numbers. Okay, this should not be too unfamiliar to you guys. Okay, and we have a name to all these numbers that we are going to introduce to you in secondary, right? As you can see, okay, so what we call here are all these are real numbers, right? We have real numbers. This is the bigger name for all the numbers that we're going to introduce to you in secondary school, real numbers. And what it consists of is both rational and irrational numbers. So what are rational and irrational numbers? Okay, I will describe to you later in details. Okay, these numbers are actually all possible numbers that can be listed on a number line. Okay, what is the number line? Okay, later I will also show you what is the number line. So basically, you are going to learn all kinds of numbers, right? So apart from the fractions and decimal that you guys are very familiar with, we are going to tell you more about what is integers, right? Okay, natural numbers are counting numbers like 1, 2, 3. Okay, and whole numbers are numbers that you have learned so far, 0, 1, 2, 3, right? Okay, whole numbers include zero. 0 is within the whole number range, not within the natural counting range. Integers. Okay, integers encompass everything. Okay, so all the negative numbers, all the positive numbers, right? Which includes -29 and -1 here. And, okay, so what is rational number, right? Okay, so rational numbers are numbers that you can actually represent in terms of a fraction, right? You guys know what's fraction, right? So I can write any numbers. Okay, so any numbers that can be represented by a fraction, a number, like 3 over 4, okay, be it negative or positive. Okay, this is called rational numbers. Okay, even decimal, you can also express them as a fraction. Like for example, 0.34 here. Okay, you guys know how to convert, right? How to convert this into fractions, right? So this is by right minus 34 over 100. Okay, so minus 0.34 is a decimal, but it can also be written as a fraction. Okay, so if the number can be written as a fraction, it's called a rational number. Okay, so bear that in mind. So now you roughly know what is rational number, right? Okay, so irrational numbers. You look at this. The way how we draw this set here is we separate the irrational numbers from the rational numbers, right? So means these two groups of numbers, they do not share the same, right? They do not have common numbers. So once you say that it belongs to the rational numbers, okay, numbers belong to rational numbers, it means that it cannot be belongs to the irrational numbers. They are totally different. Okay, they are totally different here. So what are irrational numbers? Okay, you look at the numbers and the name is, it seems like very complicated here, but what it means here is, okay, rational numbers, as what I said, right, it can be written as a fraction. So irrational, okay, on the other hand, means what? The numbers cannot be written. No matter how hard you try, you cannot find a way to rewrite this as a fraction. Okay, so a very, very common number that you all have learned, pi, right? So what is pi? Do you know what's the exact value of pi? What's the exact value of pi? Can you type in the chat and let me know what do you think is the exact value of pi to you? 3.14? Ah, okay, 3.14. Oh, okay. Never ending strings or numbers. Yes, correct, correct. Okay, so oh wow. Okay, some of you give me very a very long string of numbers. Yes, yes. Okay. Pi, because in your school usually during in your primary school teachers will always ask you to use things like 3.14 or 22/7, right? But these numbers are not the exact value of pi. They are actually estimation, right? An estimation of pi. So in actual fact, the value of pi here is a string of numbers. Yeah, it's never ending. Okay, so it's never ending string of values here. So no matter how hard you try, you will never be able to write pi as a fraction. Okay, so this is how we classify all these numbers under irrational numbers. Okay, so same thing for square root 2 also. I believe you guys have your calculator with you, right? You guys have your calculators? Okay, you can try to punch in the value of square root 2 and you see what you have. Square root 2, right? Okay, so square root 2 is also another string of values. Yes, it's 1.4142 and so forth and so etc. Right? So these two numbers, you cannot express them as a fraction. So we will call this special group of numbers the irrational numbers. Okay? So I hope you guys have a rough idea of different types of numbers. And these numbers will all be introduced, okay, to you guys in your Set 1 lessons. Okay, so here we have defined all the definitions. Okay, irrational numbers are the set of real numbers which cannot be expressed as simple fractions. Rational numbers are the set of real numbers which can be expressed as simple fractions. Okay, and your integers, okay, remember integers are the set of positive and negative whole numbers, including zero. Okay, so it includes zero here. So integer is a bigger group of numbers here. It includes the whole numbers and includes the natural numbers. Okay, and take note that zero is neither positive nor negative here. Oh, what is positive number? Okay, positive numbers are numbers that you have been learning in primary school, right? Numbers like 1, 2, 3, 4, 5, 6, like 2/3, 3/3. As long as there's no negative sign in front, they are all positive numbers. Okay, except for zero. Zero is neither positive nor negative. And whole numbers, okay, the set of real numbers will consist of zero and positive. Okay, so a very common misconception here is people always thought that zero, okay, is a natural numbers, but it's not. Okay, zero is classified under whole numbers, not natural numbers. Okay, natural numbers are numbers that you can count, right? Okay, the set of real numbers which are positive integers here. Okay, so anyone has questions regarding the different names of the numbers here? Okay, so you all have a rough idea of what are all these numbers. Okay, so we are going to look into all these numbers, especially the negative number today. Okay, okay, so if you have no questions, okay, there's another group of numbers that I didn't mention just now. Okay, you do see that this number here, 0.5 dots here. Okay, this is the number that, okay, we will also introduce to you. Okay, so what does do you see the dot now? I don't know whether you can see the dot. There's a very, very small dot here on top of the 0.5 here. Okay, so what does it means? Okay, what it means here is, okay, this is the next section that I want to talk about here. Okay, so it's the recurring decimal. Yes. So what exactly is recurring decimals? Okay, you guys have learned what is decimal, right? So what is recurring? Okay, recurring decimal is a number that can be written as a decimal with a finite number of decimal places, but results in a number of digits that repeats. Okay, so here the keyword here is repeats infinitely, right? So we can place a dot above the beginning and end of the repeating blocks of digits to indicate the numbers, the digits that repeats in the recurring decimal. Okay, a recurring decimal is a rational numbers as it can be converted into simple fractions here. Examples. Okay, when you look at this table, okay, so last time when I believe you guys have actually seen instances whereby you have things like 1/3, right? You guys have seen fractions like 1/3. And if you try to convert them to fractions, you notice that okay, when you punch your calculator, you do notice that you see a string of 3. Okay, so because of the calculator can only show you up to a maximum of 10 digits. Okay, so by right, this string of 3 will repeat itself infinitely. Okay, so it means what? It can repeat itself like a few hundred times, a few thousand times, and it's never ending. Okay, so this kind of decimal, right? It keeps repeat itself. Okay, we call this the recurring decimal. Okay, recurring means it keeps on repeating. Okay, this is what it means. Okay, 1/3 is one example. 1/9 is also another example, right? So if you try to punch your calculator and you notice that 1 divided by 9, it give you a string of numbers, 0.111. Okay, so the number that, okay, the digit itself that repeats. Okay, because we do not want to write this infinitely, right? So how do we write this on paper? Okay, so we will use a very small dot here. Okay, so that you put a small dot on the digit that repeats. Okay, so this dot means what? Means it repeats the 1 infinitely, right? Okay, so same thing here. If you look at 1/3, okay, we're going to put a small dot here. There's a small dot on top of the digit 3 here. So it means that this 3 has to repeat infinitely here, right? Okay, how about instances whereby we only have, okay, look at examples here, the fractions here, 7 out of 12. Okay, so the decimal equivalence is 0.5833333333. Okay, so the 3 repeats. So in this case, if your first two digit here, 5 and 8, they do not repeat, right? Okay, so we keep the 5 and 8 as it is. Okay, and for the digit that repeats, okay, which is the 3, the never-ending 3 behind, okay, we'll put a dot, okay, to show that these numbers will repeat. Okay, so likewise for, okay, so if you look at 9/37, it's another case also. You do notice that what repeats here is this block here, 243, 243. Okay, so if you want to indicate this block is repeated, okay, so you can actually put a dot on the first digit and another dot on the last digit. Okay, so this will shows you that this block of 243 keeps repeated, right? Okay, so here also, okay, if you want to see here, 43/99, okay, you do notice that this block here, the 434343, keeps repeat. Okay, so the first digit, you put a dot, the last digit, you put a dot. So basically, you indicate where's the start and end of the repeated block here, okay, using the dots. Okay, so this is how you write a recurring decimal on paper. Okay, when you want to write it in terms of a decimal here. So look at example 1. Okay, so which of the following numbers are rational numbers here? Okay, so recall what I said about rational numbers just now. We say that rational number can be expressed as a fraction, right? So when you look at the examples below, okay, we have different numbers here. We have 5 different numbers. -6, 4.5, pi, 6.66666. This is a recurring decimal, right? And we have a square root 3 here. Okay, so if we want to change them to fractions, okay, -6, okay, this is an integer, right? Minus 6 is the integer. So integer can be rewritten as a fraction. So this is a rational number. Okay, so you check this. This is a rational number. Okay, let's look at 4.5. 4.5, okay, when you change it to fractions, right? Okay, it's 9 over 2. Okay, so this can be converted to a fraction, so it is a rational number. Pi, okay, this one we mentioned already, right? Pi is one of the example where it's an irrational rational numbers. So no, okay, these numbers cannot be expressed as a fraction. For this 6.66666, okay, a recurring decimal. Okay, so this is how we write, right? Okay, so you learn how to write this already, putting a dot on the decimal that repeats. 6.6 and put a dot on top of 6. Okay, so this can be converted to a fraction, which is 6/2 over 3. And if you change it to improper fractions, okay, this is a mixed number, you change to the improper fractions, it's 20 over 3. So it can be represented as a fraction. So yes, it is a rational number. And the last one, square root 3, right? Square root 3 is equals to 1.732205. Okay, you can try to use your calculator and find the value of this. You notice that it's a string of numbers that doesn't end. Okay, so usually when we want to represent numbers that doesn't end, we will put a three dot behind, right? These three dots behind represents the number repeats. So sorry, no, it's not repeat. The number continues, right? It will be a string of numbers, just like your pi. Okay, it will be a string of numbers. So here, rational numbers, no. There's no way that you can rewrite square root 3 as a fraction. Okay, so does it mean, okay, so far we've seen examples like pi, square root 2, square root 3, irrational numbers. Okay, so does it mean that all square root numbers are irrational? What do you guys think? Do you all think all square root numbers are irrational? Okay, so no, no. So what examples can you think of that are not irrational here? Yes, anyone? Anyone has examples? Square root of 9. Okay, so what is square root of 9? 81. Huh? Square root of 9 is 81. Square root of 9 is 3, right? Yes, square root of 9 is 3. And 3 is a whole number, and it also is an integer, right? It can be expressed as a fraction, right? Just like this minus 6 here, right? 3 is equals to 3 over 1, right? Square root of 4 is 2, yes. Okay, so 2 is a whole number also, so it can be expressed as a fraction, right? So square root of 9, square root of 4, yes, very good. They are both rational numbers, correct. Okay, so if you want to use your calculator, you can also use your calculator, right? To check whether it's rational or irrational, because sometimes you guys think that, okay, perhaps you can't see, right? Right, for example, if you want to try out 6/2 here, right? Okay, if you want to try 6/2, okay, you do see that when you use your this SD function here, you have an SD function, okay, you can check your calculator. This button shows you this. Okay, this is basically you can change your fractions to, oh, sorry. Okay, wait now, let me cancel this. Right, so your fractions here, 6 and 2/3 here. Okay, so anyway, 6 and 2/3 is 20 over 3, right? So we can try to do this.
Changing, are you writing on the screen? It doesn't seem to be changing.
Oh,
Yeah. Oh, now
oh.
it's fine.
Can you see
Okay,
the
yeah.
calculator that I'm using here?
Cannot. I think you have to
Cannot.
share to the actual share screen because we are still
Okay.
seeing your PDF.
All right.
Yeah.
Okay, let me see. Okay. Can you see?
Yes, can see now. Yeah.
Okay, so you type in your fractions here. So when you press this SD button on your calculator, you can see this, right? Okay, so you press this, you can see that it helps you to convert into decimals and fractions, correct? Okay, so this is rational numbers, but if you try to use square root 3 here, correct? These numbers, 1.73205808. Okay, when you press this button, if you press, no matter how hard you press this button, it's not going to show you a fraction. Means what? Means this number cannot be expressed as a rational number. Okay, so it will be an irrational number. Okay, so this is one way that you can check for rational and irrational numbers here. Okay, so yeah, going back to, okay, moving on. Let's move on to the third page here. Okay, so this one. Okay, exercise one. Okay, so can you try out yourself? Okay, try to list down all the rational numbers here. Okay, there's how many numbers? There are six numbers here. Okay, can you try? Okay, choose the rational numbers here. Okay, I believe there are some numbers that are quite straightforward here, right? Okay, just now when we talk about rational, irrational, right? So probably it's easier for you to find out some. Okay, so there are some numbers that when you look at it, okay, so you might think that it could be irrational here, right? So this one, okay, we're going to look at possible irrational first, so that's easier. Okay, this one, not sure, right? You're not sure whether this tree seems like, because just now we talk about irrational numbers like pi, square roots, or sometimes if you look at the recurring decimal, you may not be able to tell very straightforward whether it's irrational or rational. Ah, okay. Okay, I'm seeing some answers from the chat here. Okay, so rational numbers. Okay, so which means actually the rest are actually quite straightforward, right? You can definitely tell that -729 being a whole number, it can be expressed as your rational numbers. 81/5, definitely yes. Okay, it's already in fraction forms, right? 2.179 is also another very clear-cut number whereby you can see that you can express them as fractions. Okay, so these three numbers are okay. The more questionable ones are the three that I circled. Okay, I see answers. Okay, yes. Okay, minus square root 9/4 it is. Okay, because as mentioned just now, okay, some of you which you guys had pointed out, right? Square root 9 is actually -3/4. So yes, it is also, right? So the remaining two, square root 5 and 4.54, are they rational numbers? 4.54 is a rational number, right? How do you know 4.54 is a rational number? How can you write 4.54 as a fraction? Okay, so 4.54, 545454, right? So you can write 4.54 as a fraction too, yes. You can try to use your calculator to check, okay, and see whether you can convert this into a fraction. Yes, correct. 4.54 is indeed, okay, this one is supposed to repeat, huh? So we're putting two dots on top. So it's supposed to look like this, something like this, right? Okay, it's 50/11. Yes, you're right. Okay, so it can be written as fraction. So in fact, the only irrational number here is this one, square root 5. Okay, so the rest are all rational. Okay, only square root 5 is not. Okay, very good. Now I think you guys have get a hang of it, huh? Okay, so without further ado, let's look at the negative numbers that I talked about just now. So the focus here today is actually more on negative numbers. Okay, because you guys will be exposed to negative number more commonly here. Okay, so in primary school, you have seen many different types of numbers, and in secondary school, you'll be exposed to negative numbers here. Negative numbers are numbers that are smaller than zero. Okay, so when we talk about negative numbers, okay, we have a concept called the absolute values. So what does absolute value means? Okay, when we look at absolute values of any numbers, any real numbers here, we are only interested in looking at the number. Okay, we are interested in looking at the number. We do not care about whether it's a positive or negative number here. Okay, the negative sign show you that this number is negative. Okay, so if we like to talk about absolute value, we are only looking at this number here. So the absolute value of this number negative 12 is 12. Okay, so we are only looking at what we call the magnitude, or the numbers. Okay, so we do not care about the sign if we are looking for absolute value here. Okay, number line. So what is the number line? Okay, so number line is usually used to represent real numbers. Okay, so if you look at the diagram here, okay, you see there's a line here. Okay, this line, by right, it will stretch towards the left and towards the right. Okay, and what's in the middle is the number 0 here. Okay, so we have a number 0 here in the middle. Okay, remember just now we say that 0 is neither negative or positive here, right? So it does not belongs to the negative range, nor it belongs to the positive range, but it sits right in the middle of the number line. Okay, so here the markings on the number line is actually equally spaced, and the arrow shows that the lines goes on indefinitely in both directions. Okay, so what it means here is this number line can continue towards the left and continues to the right. So when you look at the side where there are all the positive numbers, 1, 2, 3, 4. Okay, you guys know, right? It will goes on to 5, 6, 7, 8, and so forth, right? So if you look at the negative numbers, it's the same thing. Okay, it applies. Okay, it goes from -1, -2, -3, -4, and it will also continues -5, -6, -7, and so on. Okay, so it is like so-called a mirror image. The negative numbers. Okay, the only difference when you represent the numbers on the right line is positive. It increases the numbers from left to right. Okay, but for the negative range, okay, it decreases from the right to the left. Okay, so what I mean here is the number on the left is always smaller than the number on the right. Correct? So if you look at the positive range, you know that 1 is smaller than 2, 2 is smaller than 3, 3 is smaller than 4, and so forth. So what it means here, when you look at the negative side, -4 is smaller than -3, -3 is smaller than -2, -2 is smaller than -1, and -1 is smaller than 0. Okay, so in terms of when you think of looking at the numbers, okay, this will be a bit confusing for the first time if you are looking at comparing numbers, especially comparing negative numbers. Okay, because you're very used to seeing 4 is bigger than 1. But in the negative range, it's the other way around. Okay, -4 is smaller than -1. Okay, so this is something that you have to adjust yourself, okay, to remember. If you cannot remember, so always draw a number line to help you visualize. Okay, which numbers are less, which number is smaller, which number is bigger here. Okay, let's try example 2. Use a number line to illustrate each of the following. Okay, so if you look at this first example, we have number 0, -1.5, and 2. Okay, so if you draw a number line here, okay, so you know that your range covers from 0 to 2, and this -1.5, okay, the nearest whole number, okay, it will be a best practice that you actually do the markings, okay, draw the markings to the nearest whole number here. Okay, so Likely, okay, after you check the numbers, you know that you should draw your number lines from like -2 to 2. Okay, so you draw your number line -2 to 2, and then you put equal spacing for the numbers in between, like number -1, 0, and 1. Okay, so now you can plot. How do you plot? You use a black dot, right? Do a black dot to plot the point here. So this one, 2 is here. Plot the point on 2, 0, plot the point on 0. And then for -1.5, you know that it's somewhere in between, halfway between -1 and -2. Okay, so you're going to plot -1.5 here. Okay, so after you plot, you can compare. Because remember, we say that the number on the right is always bigger, right? Right? So 2 is bigger than 0, 0 is bigger than -1.5. Okay, look at part B. Okay, part B, now we have a mixture of decimals and fractions. Okay, so how are we going to locate all these four numbers? Okay, first, of course, you need to determine the range of the number line that you are supposed to draw. So the numbers is actually somewhere between -2 to 1, right? So, okay, so you're going to put all the numbers here. Okay, let's put in all the easier numbers like the ones. Okay, you can put in the easier numbers 1, 0.5. Okay, 0.5 is somewhere, some 0.5 is half, so it's actually somewhere between 0 and 1. So you put this somewhere between 0 and 1, halfway. And numbers like -0.25, -1, 1 and 1 quarter. Okay, these two, okay, I believe at this stage of time you all know how to convert, right? Okay, you can either convert it to fractions or decimal. Okay, whichever is easier for you to see. Okay, so if you want to convert this -0.25 as a fraction, you know that it's 1 -1 quarter. Okay, so it is halfway between 0 and 0.5, right? 1 quarter is between 0 and 0.5, but this is negative, so you're going to put it between 0 and -0.5. So you're going to plot it somewhere halfway between 0 and -0.5. So likewise, for -1 and 1 quarter, okay, it must be somewhere halfway between -1 and 1, -1.5. So you're going to plot it somewhere in between. Okay, any questions so far? Okay, so if you look at part C, okay, this time around they're asking you for positive integers less than 5. Okay, so what are the positive integers that are less than 5? Okay, so integers basically, okay, encompass positive and negative number, right? But here, when you look at positive integers, so they are actually asking you for numbers that you guys are very familiar with. Okay, actually the numbers that are less than 5 here. So what are the numbers that are less than 5? Okay, so we do not need to look at the negative range because they're asking for positive. So numbers that are less than 5 includes 4, right? Because it's less than 5, 3, 2, 1. Okay, so if you want to show using the number line, okay, you are supposed to plot these 4 points here. Okay, remember our integers are whole numbers, right? So only these 4. These 4 numbers fits the criteria here. And part D, integers between -2 and 2. Okay, so when you say between, does it include -2 and 2? It doesn't, So between doesn't include -2 and 2, So we are only interested in writing down the numbers, okay, starting from -1, 0, and 1. Okay, so these 3 are integers, okay, between -2 and 2. Okay, so can you try out drawing the number lines yourself for exercise 2? Okay, practice drawing the number lines and see whether you can plot these numbers on the number line. Okay, so first thing you need to determine what's your range, right, to draw your number lines. So I see numbers like minus 1.5, so probably I will start minus 2 on the left side. 2.5, maybe I have 3 on the right side. Okay, because I know 2.5 is between 2 and 3, minus 1.5 is between minus 2 and 1, minus 1. Okay, so try to draw your number line as equally spaced as possible, right? And for part B, right? Okay, so same thing here. If you look at the numbers, I have 1 and 3 quarters. So likely I will put 2 here. And I have minus half, so minus 1 here, right? So I'll put my numbers, try to equally space the numbers as much as possible. Okay. Okay, so for part A, how do you plot? Okay, 1. 1 is the most easy. Okay, so I put a black dot here on 1. And then I have minus 1.5, somewhere in between minus 1 and minus 2, right? Okay, minus 1.5 is somewhere here. Okay, so you can also label your numbers here so that you know that this is 1, this is minus 1.5, and I have 2.5, so somewhere between 2 and 3. Okay, do you get these answers? Okay, so for part B, okay, so I have 0. Okay, 0 is here, right? I have 1, 1 is here, and I have minus half. Okay, minus half somewhere between here, somewhere in the middle. Okay, put a dot here. And the last one, 1 and 3 quarter. Okay, so you roughly estimate your halfway is somewhere here. So 1 and 3 quarter should be somewhere here, right? So this is your 1 and 3 quarter. Okay, so this is how you plot, okay, your numbers on the number lines. Right? Anyone has questions? Okay, let's look at the next part here. Okay, the inequality sign. Okay, so far, okay, I believe you guys have already seen things like less than equals to, greater or equals to. Okay, but do you know that there's actually a symbol to represent all these words here? Okay, so the corresponding symbols, okay, to represent all these words are shown here. So when you look at this, this is a less than sign. Okay, so how do you know this is less than? Because this one, okay, when you compare two numbers, like for example, 2 and 3, right? Okay, you can say that 2 is less than 3. Okay, so the smaller number, this pointy part of the symbol will point to the one that is a smaller number then. Okay, so you know that this is 2 less than. Okay, this symbol means less than. Okay, so if you want to include your equals to, right? Equals to means the numbers can be the same or less than. Okay, so here, okay, besides putting the less than sign, you can include a straight line below. Okay, this will represent your less than or equals to here. Okay, greater than. Okay, so example, 5 is greater than 4. Okay, look at this number, the pointy one. The pointy part will always point to the smaller side, huh? But how you read this diagram is you read 5 is greater than 4. Okay, the big mouth will point to the big number, the small pointy part will point to the smaller numbers. Okay, so likewise, if you want to include the equals to, okay, you just put in the straight line below. Okay, so let's look at example 3 on how to use the symbol here. So fill in the blanks with smaller than or greater than sign. Okay, so when you look at 5 and 8, the smaller number is 5. So the pointy part will point towards the smaller number here. Okay, so we are using this sign. This sign is smaller than. So when you compare numbers like 0 and minus 3, okay, so remember, a negative number is always smaller than 0. Okay, because it's on the left side of the number line. Okay, so you can draw a number line if you're not unsure to check where's the position of minus 3 here. Minus 3 is the smaller number. Okay, so the pointy side will point towards minus 3. So this means what? This means 0 is greater than minus 3. Okay, part C. Okay, a negative number is definitely smaller. All the numbers on the left side is smaller than the number on the right side. So a negative number is definitely smaller than a positive number. Okay, so you use the smaller than sign here. And for part D, 6, positive number, -7, negative number. Okay, so 6 is a bigger number, so it's greater than -7. Okay, I believe this is quite straightforward. Okay, can you all try question 3A? And can you all tell me what's the answer in the chat? Okay, they are actually the small than and greater than sign on the keyboard. So I believe you all can type in the answers in the chatbot. Okay, I see people giving me answers for the part A already. Yes, a negative number is definitely smaller than 2, right? Okay, negative number is smaller than 0, yes. Okay, 3 is smaller than 4. Okay, D, yes, greater than, very good, huh? So you see, when you compare 3 and 4, okay, you do see that 3 is more than 4, but in the negative range, -3 is greater than -4. Okay, I think you guys need some time for the fraction and decimal part. Okay, so yes, this one quite clear. 0.09 is bigger than 0.07. I do see some struggles for the fractions and the negative numbers here. Hey, someone give me the whole set of numbers, whole set of answers already. E is greater than, yes, half is greater than 1/4, right? Okay, and F, okay, so F is, okay, so if you look at part C and part D, right, you do note that with negative sign, okay, it becomes the opposite here, right? So if half is greater than 1/4, it means that negative half will be less than your negative 1/4 here. Okay, and the last one, -0.13 is greater than -0.15. Yes, very good, correct. Okay, I believe you guys, oh wow, very good. I see all the correct, oops, sorry. I see all the all the correct answers coming in here. Yeah, okay, yes. Okay, very good, huh? You guys know how to compare the numbers. So let's move on to exercise 3B. Okay, use a number line to illustrate each of the following. Okay, so here we are looking for a range of numbers, right? So part A, negative numbers greater than -5. So draw out the number lines. Okay, once you draw out the number lines, it's very clear that you can see that you want numbers bigger than. Okay, this is greater than. Remember, this sign means greater than. Okay, so you are looking for all the negative integer that's greater than -5. So anything numbers that's greater than is all on the right side. So that will be -4, -3, -2, -1. And we can stop here because they only want negative numbers. So greater than does not include your -5. So these are the numbers. -4, -3, -2, and -1. Right? Okay, for part B, okay, so the integers between -3 and -1. And this sign, remember this one, what does it mean? It means that this is less than or equals to, correct? Same thing here. Both represent less than or equals to. So you need to include these two numbers here. So it's minus 3, minus 2, minus 1, 0, 1. So you want to include all the integers between minus 3 and and 1, and inclusive. These two are included. Okay, that one means equals to. So you're going to include minus 3 and 1 and those numbers in between. Okay, so these five numbers are the numbers that we are looking for here. Okay, so if you all have no questions, I'll move on to the next part. Okay, I hope you guys have a rough idea of what negative numbers are for now. Okay, so as you know, okay, the next thing that we are going to introduce will be how to add and how to subtract the integers. Right? So how are you going to go add and subtract integers? Is it the same as what you have been doing for adding and subtracting positive numbers here? Okay, so here let's look at how we can add and subtract here. Looking at example 1. Okay, if you have things like 2 minus 5. Okay, so using a number line, okay, will help you to visualize how to do this kind of subtraction here. Okay, so if you look at this, the first number, we will take the first number as the starting point. First number as the starting point. Okay, so if you look at the number line here, okay, I locate where is the position of 2 on the number line. Okay, so how do I subtract minus 5 here? So when you want to add a number, okay, you move the number of units to the right. Okay, when you want to subtract, okay, add, move to the right. Subtract, you move to the left. Okay, so for this case, we are going to move 5 units to the left. Why? Okay, because it's minus 5. Okay, so to show minus 5 here, okay, so your starting point is 2, right? Just now we say that the first number is the starting point, which is 2. So we are going to move 5 units towards the left, right? 1, 2, 3, 4, 5. And you found that you land yourself at this number minus 3, correct? This number minus 3 here. Okay, so this means what? This means 2 minus 5 is equals to minus 3. Okay, so the final position which tells you the results here. Okay, I believe this is not difficult to understand. So for exercise 1, okay, let's try. Let's try to draw this on the number line using the same way shown here. Okay, shown in the exam, the question just now. So here, what is my starting number? Is it minus 3 or 4? Which one should I put as a starting number here? Yep, it's minus 3 or 4. Minus 3. Yes. Okay, so I'm going to start off from minus 3. Minus 3 is somewhere here. Okay, the reason why I know I have to put it here is because I know this is plus. So I'm going to move. Plus means I have to go move towards the right, right? Just now we said. Okay, because left, the number will get smaller. Right, the number will get bigger. So plus means your number will get bigger. So you will need to move towards the right. Correct? So let's say I just put in some numbers. Okay. Okay, I also don't know where it will land. But anyway, just put in more numbers like just in case. And you know that plus 4 means you're going to jump 4, right? So how are we going to jump? 1, 2, 3, 4. Right? Every time you plus 1, so you're going to jump 4 times. And you notice that you end up at the final position 1 here. Okay, so what it means is minus 3 plus 4 goes to 1. Okay, pretty simple to understand, right? This thing. Okay, so this is doing the adding and subtracting of negative numbers. Okay, so there are actually different cases, right? So there are some common cases that we want to discuss here. So one of the cases that we want to discuss here is the addition of two integers with the same sign. Okay, so if you add 6 plus 2, right? 6 plus 2, you guys know, right? It's 8. 3 plus 9, 12. Okay, but how about adding the negative numbers here? So if you have negative 12 plus negative 11, how are you going to add? Okay, so here we know that both of them have a negative sign. Okay, so one way that you can do is you take out the negative sign for both numbers, right? This only applies when you have both are negative numbers. So you can take out the negative sign, and what you can do is you do the operations 12 plus 11. Okay, 12 plus 11, that will give you 23. Okay, so if you have the integers with the same sign, you can actually look at the numbers only. Okay, so you can put the negative side aside first, add the numbers. Okay, so 12 plus 11 is 23. Then you remember to put your negative sign back here. Okay, so similarly, when you look at part D, okay, we'll be doing the same thing here. Okay, so you need to know that both numbers must have the negative sign in order to do this. So you can take out the negative sign and put them aside first, right? And then you add the numbers. Okay, add the numbers. Then this will give you 25. And then you remember to put back the negative sign here. Okay, so minus 15 plus minus 10 gives you negative 25. Okay, so can you try out yourself for exercise 2? Okay, I think for A and B, it's quite straightforward. I'll just give you the answers. Okay, so the focus here is more on adding the negative numbers. Okay, can you try part C and part D? How to add the numbers? Okay, so I see answers coming in for part C, minus 23 and also minus 44. Okay, so yes. Okay, so can you do notice that these two numbers, they have negative, right? Negative plus negative 13. Okay, so we take out the negative sign and then we add the numbers, right? Okay, so this is negative 23. And for part D, okay, so we notice that there are negative sign for both numbers. So, okay, so we put negative aside and then we add the number. Okay, so 23 plus 21 is 44. So, yes, okay, I see all the correct answers from the chat. Okay, so for part C and part D, these are the answers. Okay, so I think you guys are very good at this. So let's try another type here. Okay, addition of two integers with different sign. Okay, so this is a little bit more challenging than the one that is shown earlier. So now we have two different sign here. One positive number and one negative numbers. So what can we do here? Okay, if you look at the solution for part A, so 4 plus minus 2. Okay, so plus minus. Okay, so for plus minus, we can actually change it to minus. Okay, adding a negative number is the same as subtracting. Okay, so plus minus, you can change it to minus here. So 4 plus minus 2 is equals to 4 minus 2. Okay, which is equals to 2. Okay, so using the same idea, okay, this one minus 3 plus 1. Okay, so how am I going to do this? Okay, if you cannot see how to solve this, okay, as a start, you can also use your number line method, right? Just now you remember. Okay, so this one, okay, is a little bit hard to see, because this, or, okay, so either you use the number line method that we showed you earlier, Or you can actually try to rewrite this into 1 minus 3, right? So this is minus 3 plus 1. Okay, so you know that when you add two numbers, right? Like 1 plus 2 is the same as 2 plus 1. Okay, so likewise for 1 plus minus 3, sorry, minus 3 plus 1, you can also rewrite this as like that. 1 plus minus 3, right? Okay, so if it's 1 plus minus 3, then it will work the same, right, as your part A. Okay, 1 plus minus 3 is the same as 1 minus 3, right? Okay, so 1 minus 3 is minus 2. Okay, there are different ways to show. Okay, can try the best method that you can see from here. Okay, the number line is another way, right? Minus 3, starting point is minus 3. Okay, so we say that this is plus 1. So you end up as the number minus 2 here. Okay, so different ways that you can try. Okay, see which method works best for you. And part C, okay, same thing here. 7 plus minus 11. Okay, so plus minus, you can, okay, so adding a negative number is the same as subtracting the numbers. Okay, so you can change your 7 plus minus 11 to 7 minus 11. Okay, and this will give you minus 4. And part D, minus 7 plus 15. Okay, so minus 7 plus 15. Okay, this one, if you want, you can also flip this to what I shown here in part B. Okay, so this one, you can actually change it to this, right? 15 plus minus 7. Okay, you know the plus you can swap, right? So if you can swap this 15 plus minus 7, and using what we seen earlier, okay, this is the same as 15 minus 7. So this will be 8, right? Okay, so can you try out exercise 3? Okay, see who can tell me the answer the fastest here. Okay, this will be a bit more challenging. Oh, okay, that's very fast. I have someone who typed in the answers, but whether it's right or wrong, let me double check. Okay, Raiden. Okay, Raiden, you didn't get all the answers correct here, but you are very close to getting all four answers right. Okay, maybe you have to check your part A again. Okay. Okay, I think someone has given me all the right answers already, yeah? Let's see. Minus 3, 8, 17 minus 1. Yes, okay, I think Wai Ming, right? Wai Ming. Yeah, you got the correct answers. Okay, very good, huh? So A here, okay, minus 9 plus 6, right? So you can rewrite this as this. So this will be 6 minus 9, which is equals to 3. B, minus 4 plus 12, same as 12 plus minus 4. 12 minus 4, which is 8. C, 32 plus minus 15. 32 equals to 32 minus 15, which is 17. And the last one, 11 plus minus 12. Okay, so this is 11 minus 12. Okay, so this is a bit hard to see, but okay, if you look at this is the same as minus 1. Yes. Oh, sorry. I think the first part I forgot about the minus sign here. So this is minus 3, 8, 17, and minus 1. Okay, very good, huh? I hope you guys give me the answer without using your calculator. Okay, so if you are not using your calculators, yes, you're very good at doing this already. So any questions so far? Okay, if not, I'll have to move on to doing subtractions. Okay, so let's move on to do subtractions. Okay, so the first case, we are going to do subtractions with the same sign. Okay, let's look at example 4. Minus 4 minus 6. Okay, what is this? Minus 4 minus 6. Okay, so how do you subtract a negative number from a negative number? Okay, just now we say that when you have plus negative, it becomes negative. So here, negative minus negative, it becomes positive. Okay, so you'll be wondering how come? Negative become positive, right? Okay, it's just like same as what you see as flipping a coin here. So if you flip, okay, negative, let's say we say that negative means flip once, right? So if you have a head facing upwards, when you have a negative, you flip the coin, and then it becomes your tails facing upwards. Okay, negative means you flip again the coin. So when you flip the coin again, you get the head again. So negative means you're flipping a coin 2 times, and you get back the same face, which is positive. Something like this. Okay, it adds some kind of this kind of similar idea here. Negative give you positive. Okay, so minus 4 minus 6 will give you minus 4 plus 6. Okay, so you're going to change all the negative minus to plus here to solve this kind of um, problem here. Okay, so for part B, if you look at this, minus 14 minus 6, okay, your minus, you can rewrite that as plus. Okay, so this becomes minus 14 plus 6, which is equals to minus 8. Okay, so we are going to use this same method here. So even for part C, minus 2 minus 3, this minus, you can rewrite this as plus. So it will be minus 2 plus 3 equals to 1. Okay, likewise for part D, minus 7, okay, minus again, right? So minus become plus. So it will be minus 7 plus 7 equals to 0. Okay, so let's try out. Let's try out yourself for exercise 4. Okay, same thing here. I hope you guys do not use the calculator and tell me the answer. Oh, okay. I already have answers in the chat. Well, you guys are very fast, huh? Okay, so part A, let me see, do I have the correct answers here? Okay. Oh, okay, this time around I do not have all correct answers, huh? Okay, those who say it's 18 for part A, you have to relook again. Okay, the answer is not 18 for part A. Okay, I do see the, okay, there's a mix, huh? Oh, okay, I start to see a bit of confusion here already. Okay, never mind, let's do it one by one here. Okay, so for part A, okay, so minus 12 minus 6. Okay, so what do we say? We say that we want to change your minus to plus, right? Okay, so here we have minus, we changed it to plus. So this becomes minus 12 plus 6, right? So minus 12 plus 6 is definitely not 18. Okay, minus 12 plus 6 is not 18 here. It's minus 6, right? This is minus 6, huh? And for part B, minus 5 minus 19. Okay, so using the same method, minus 5 plus 19. Okay, your minus becomes plus, right? Okay, so if you cannot see, right? Okay, so we know that if you add a number, you can change the sequence here, right? So this will be same as 19 minus 5, which is 14. And C, minus 11 minus 5. Okay, so the important thing here to note here is you need to use this method to change this to plus. Minus minus become plus. Okay. This will give you negative 6. Okay, the last one. Okay. For positive, this only works if you want to swap the order, this only works for adding. It's not going to work for subtracting. Okay, so do you all have these answers? Okay, let me see if you have any questions. Okay, yes, some of you tell me you got the answers. Very good. Okay, so I'm going to move on to the next part here. Okay, the subtraction of the two different integers with different sign. Okay, so for integers with different sign, okay, look at example 5 here. So how do we solve 4 minus 2? Okay, so it applies the same thing here again. So the minus minus will become plus, right? So 4 minus 2 become 4 plus 2 equals to 6. Okay, so and part B, look at this, same thing here. 3 minus 13 is equals to 3 plus 13, which is equals to 16. Okay, so same method used here as what you have seen in the earlier example. So can you all try exercise 5? Okay, very fast. Let me see some answers. Okay, so most of you tell me it's 61 and 15. Yes. Okay, so okay, so you guys have improved already, huh? Okay, just now there was quite a confusion, but now I think all of you have got the hang of it. Yes, so this is 27 plus 34, right? So this gives you 65. Okay. No, no, 61. Okay, sorry. And this one, 2 minus 13, right? Is the same as 2 plus 13, which is 15. Okay, very good, excellent. Okay, so all give me the right answers here. Okay, let's move on to combine. Okay, so if you are given a combination of addition and subtractions. Okay, so what you need to know here is if you remember that your plus minus plus minus becomes a minus and minus minus becomes a plus. Okay, so if you apply this, okay, so you wouldn't have any issues. Okay, no matter how long the operation or the expression is, right? So here, look at part A. We have minus 5 minus 7 plus 11. Right? So what we do here is we always solve from left to right. Okay, if you don't know how to because for the first time, right, when you're dealing with all the negative numbers, so if it's too difficult for you to decide what to do first, okay, so probably the best way, I mean not the best way, the first approach you want to take is to solve from left to right. Okay, so minus 5, minus 7. So let's focus on minus 5, minus 7 first. So how do you solve minus 5 plus minus 5 minus 7? Here. So you can actually flip No, sorry, you can't flip. Minus 5 minus 7. This will give you minus 12, right? So when you solve minus 5 minus 7, so you remember that just now we said that if they have the same sign, right? So we can actually take out the negative sign first, right? Then we add the number, correct? So this is how we find the first two numbers, minus 5 minus 7 is equals to minus 12. And then after that, okay, so you move on to, you do minus 12 plus 11, right? Minus 12 plus 11 is equals to minus 1. Okay, so if you want, you can do the way that I showed you earlier, where you can change the position for addition. Okay, so minus 12 plus 11 equals to minus 1, right? So you look at part B. Okay, so same thing here. So if you don't know how to solve, okay, the first approach you want to take is always solve from left to right here. Okay, so 20 minus 3, okay, this is 17, right? This one you guys should know already. Okay, how to subtract positive numbers. So here again, 17 minus 9 is also another positive number minus a positive number. Okay, so this is something that you already know. So it's 8, right? So up to here, okay, the last part here, you need to add a negative 2, right? So 8 plus minus 2, right? And what did we say just now? Plus minus becomes minus, right? Okay, so hence, you see, we end up having this 8 minus 2 here. So 8 minus 2 is equals to 6. Okay, look at part C. 9 minus 16. Okay, 9 minus 16. So this will be equals to minus 7. And minus 7 plus minus 12. Okay, plus minus, you'll remember, I'll change it to minus. So minus 7 minus 12. This will give you minus 19. Okay, and the last one, part D. Uh, so this one, 13 minus minus 4. Okay, so minus minus, remember, right? Just now we say minus minus. When you do minus minus, you change it to 13 plus 4, right? So this is what you see here, 13 plus 4. And then plus minus become minus, right? So it becomes minus 1. So 13 plus 4 is 17, minus 1 gives you 16. Okay, I think I have a question from the chat. I thought 7 wasn't negative. Are you referring to part C? Iris, are you referring to part C or part A? I'm not too sure which one you're referring to.
Oh, Changi, she's referring to part A.
Part A.
The minus 5, minus 7.
Oh, okay. Minus 5,
Yeah.
minus 7. I thought 7 wasn't negative. Okay, can. Okay, it's okay, so yes, you can see that this is subtracting 7 here, right? So minus 5, minus 7, how would you want to do this? You can actually also, okay, minus 5, minus 7. Okay, that's the tricky part, huh? Because we say that just now, we did say that plus minus becomes minus, right? Correct? So if you want, you can actually see this as minus 5. Okay, minus 5 minus 7 is the same as minus 5 plus minus 7. Do you agree, Aris? Subtracting 7 is actually same as adding a negative 7. Okay, so if you see it this way, you can use the method that I show you here. This, right? So it's the same thing. You are taking the negative side out. Okay, put it aside. Then you add 5 and 7. Correct? So if you can see this, then you should be able to link. It's the same. Okay? So subtracting 7 is the same as adding a negative 7 here. Hey, Iris. Okay, so can you try questions? Oh, sorry, exercise 6 here. Okay, I have some answers coming in. Okay, yes. Okay, so I already have the answers, correct answers from Wai Ming and also Kit Han. Yes. Okay. Okay, so minus 9 minus 2. Okay, sorry, minus 9 minus 2 plus 3. Okay, this is equals to minus 9 plus 2 plus 3, which is equals to minus 4. Part B, 12 minus 4 plus minus 3 is equals to 8 minus 3, which is 5. Part C, 27 minus 3 plus minus 2 equals to 27 plus 3 minus 2. This is equals to 28. Okay, and the last part D, 2 plus minus 7 plus minus 5. Okay, is equals to 2 minus 7 plus 5. Okay, so this is equals to 0. Okay, excellent. I have all the answers right? From what I see. Hey, very good. All right, so you guys have sort of sort of get a hang of it already, right? Okay, so let's look at the work problems here. So if a mountain is located at a height of 1,325 meters above sea level, okay, while a city is at a height of 3 meters below sea level, so find the difference in the altitude between the mountain and the city. So here you need to know how to read the word problems here. So above means positive, huh? Above this is positive number. Then if it's a height of 3 meters below, okay, the below means it should be a negative here, negative 3. Yeah? So to find the difference, it will be positive 1325 minus 3. Okay, so this one, you know that it's plus, so it becomes 1328 here, right? Okay, so you need to understand the word above and below. What does it mean? Okay, if you look at exercise 7, the average temperature of a particular city on Monday night is negative 12 degrees Celsius. So the next morning, the average temperature rises by 7 degrees Celsius. Find the average temperature in the morning, right? So how do you find this? Okay, to find the average, okay, you are supposed to add, right? You all remember you all learn average, right? In primary school. So to find the average is to find the sum of the two numbers here, right? Oh, sorry. No. Sorry. Okay, so it says that this number minus 12 degrees Celsius, okay, is the temperature for the Monday night. So the next morning, okay, so the temperature rises by 7. Okay, sorry, nothing to do with the average here. So you're supposed to use these numbers, okay, minus 12. Okay, rise, right? Rise means increase. Increase means plus 7. Okay, so minus 12 plus 7 give you minus 5 degrees Celsius. Okay, and part B, the average temperature on the Tuesday night. Tuesday night is the next day already. Okay, night is 8 degrees Celsius lower compared to the morning. Right? So if in the morning it's minus 5 degrees Celsius, okay, this is the temperature for Tuesday morning. Tuesday night, right? Tuesday night it increases. Is it increases? No, sorry. Lower. Lower means minus, right? Lower means minus 8 degrees Celsius. Okay, so minus 5 minus 8 degrees Celsius will give you minus 13 degrees Celsius. Okay, so you need to read the word problem to understand rises means plus, lower means negative, right? And if no questions, let's move on to 1C. Yeah? So we have done adding and subtracting. So we're going to do multiplication and division here. Okay, so for multiplication and division with the same sign, okay, so multiply the two integers with the same sign means, okay, when you multiply a positive number with a positive number, you get a positive number. And when you multiply a negative number with a negative number, you will get a positive numbers. Okay? So you do see some patterns here. So just now when we do negative, negative, it become positive. So here negative times negative will also give you positive. Okay, if you look at example 1, 5 times 4 equals 20. Okay, this one you all know, right? 15 times 3, 45. So part C. How when you multiply a negative number and negative number, minus 3 times minus 4, okay, because remember the rule here, positive times positive give you a positive number, negative times negative give you a positive number. Okay, so when you have two negative numbers, the negative times negative will become positive. And usually we do not write the positive here. Okay, we only put in the sign negative when it's negative, positive we leave it as like this. We do not put in the positive sign. Okay, so part D, same thing here. You multiply two negative numbers, you get a positive number. Okay, so exercise 1. Okay, bearing in mind that your negative times negative become positive, so what do you think are the answers for all this? Okay, yes. Okay, so basically because of all the negative sign here, they all becomes positive, right? All the negative here, negative times negative, you notice that, right? Every time when you have negative times negative, okay, this become positive. So what you need to multiply is actually the numbers itself. 5 times 9 give you 45. 3 times 4 give you 12. 2 times 7 give you 14. And then 6 times 4 gives you, oh, sorry, minus 6 times minus 4 is the same as 24. Yeah, very good. So I see all the right answers coming in. Okay, so let's look at the situation where we have multiplying two integers with different sign. Okay, so plus times a positive number times a negative number give you a negative numbers. And likewise, okay, a negative number times a positive number will also give you a negative numbers. Okay, so let's apply. Okay, in our examples here. So you can see part A, 4 times a positive times a negative number. Okay, you still get a negative number. Okay, and then for part B, positive number times a negative number, you get negative numbers. Part C, negative numbers times positive number, you get a negative numbers. And part D, a negative numbers times a positive number give you a negative numbers. Okay, so as long as one of the numbers is negative, the other one is positive, you always end up with a negative results here. Okay, exercise 2. Okay, so all the examples here, you do notice that they are, okay, one of them is positive, the other one is negative. Positive, negative, positive, negative, negative, positive. Okay, so what do you think is the answers? Okay, very good. So A, okay, I'll just write down the answers. I think you guys know how to find the answers. So yes, the answer is A minus 72. This one is minus 39. C minus 9. And D minus 36. Okay, so here, okay, what I believe you guys know how to multiply the numbers here. So the question here is whether there's a positive or negative results here. Okay, so whenever you have a positive times a negative or a negative times positive, okay, you will always get a negative answers here. Okay, so same thing here. So we are going to look at all operations here, which includes addition, subtractions, multiplications, and divisions. And on top of this, okay, we have something called the brackets, right? Okay, so if you have operations involving all four operations and also the brackets, okay, there is so-called a rule to perform the operations. Okay, so let's look at the rules here. Okay, if an expression contains brackets, so you are supposed to do this first. Okay, this is list in orders of the steps here. So the very first thing that you need to do, once you see a bracket in the expressions, you need to operate it first. Okay, so you need to simplify the expressions within the brackets. If there's more than one bracket, okay, simplify the expressions within the innermost. Okay, what do I mean by innermost? Like example, you have things like this. Okay, so like this. Okay, you do see that we have a round brackets here, and we have a outer bracket. Okay, the round bracket is so-called the inner bracket. The square brackets is so-called the outer brackets. So, okay, this is by 2 times. So in this case, we are supposed to solve the inner bracket, which is this. 3 plus 5 equals to 8. Okay, then you move on to do things like 2 times 8, which is on the outer brackets. Okay, so this is what we mean by innermost and outermost bracket here. Okay, so after you solve all the expressions within the brackets, okay, the next one that you need to solve is, okay, here, the only addition and subtractions or only multiplication and divisions. Okay, so in this case, we are saying that, okay, so if you have, okay, after you solve all the brackets, if you see that all the operations is only addition and subtractions only, okay, so you're supposed to work from left to right, okay, and okay, if another scenario, not the same case really, another case whereby you see all the expressions, there's only multiplication and division, okay, you also work from left to right. So this is because we so-called the addition and subtraction, they have the same priority, same rank. Okay, multiplication and division, they have the same priority here. Okay, so if you have addition and subtraction, you're supposed to work from left to right. And if there's only multiplication and division, you also work from left to right. But what happens? Okay, what happens if you have all four? Four, you have division, you have multiplication, you have addition and subtractions. So by right, you should be doing the multiplication and division first. Okay, they have a higher priority over addition and subtraction. Okay, so remember, so the order is basically do the bracket first. Second, look out for any look out for any multiplication divisions. So you're supposed to solve that first. Then the third, right? The third case is then you look at all the addition and subtractions. Okay, let's look at example 3 to understand the whole picture here. So let's say I have this case 2 plus minus 10 divided by 5. So which one should I solve first? Okay, so you do notice that there's a bracket here. Okay, but this bracket itself only holds a number. There's no operations, right? There's nothing to do here. Okay, so this bracket is just to tell you that this is negative 10, but there's nothing inside. There's no like negative 10 plus 1. There's no operation for you to do. So the next one that you're going to look at is, do we do the plus or do we do the divide first? Plus or divide? Yes, do we do plus or divide? Okay, so we will do the divide first. Okay, so divide first. Okay, so here, if you look at the solution, we do the divide, then we do the plus. Okay, so that's the order. So for part B, you look at this, 4 plus minus 13 times 2, and we have two brackets, but this bracket is only showing minus 13. So we are going to operate what is inside the square brackets, which is 4 plus minus 13 times 2, which is 4 minus 26. Okay, so after you finish this portion here, so you have to solve everything within the brackets. So 4 plus minus 26 is minus 22, divided by 11, that gives you minus 2. Okay, so let's look at the next part here. So, okay, if you want to solve this, okay, how to solve this? How can we solve this? So for part A, okay, so here we have minus 2 times 3 plus 2 times minus 3, which is equals to minus 6 plus minus 6. which is equals to -12, right? So we are going to do those multiplication first before we add the numbers, correct? And then part B, okay, 30 minus, okay, sorry, yeah, 30 minus your, this square brackets minus 5 squared minus 4. Okay, so we are going to do the bracket first, the square brackets. So this will give you 25 minus 4, right? So this is 30 minus 21, which is equals to 9. Okay, and part C, minus 3 squared times 2 minus 20 divided by minus 5. This is equals to, okay, so minus 3 squared is 9 times 2 minus, okay, 20 divided by 5 is what? Minus 4. Okay, so 9 times 2 is 18. Okay, so after you solve for this, okay, then you move on to do your minus, right? So this is equals to 22, right? And then for part D, okay, your part D, okay, you have 25 divided by 5 times 2 minus, minus 2 minus 1 minus 3. Okay, this is equals to, okay, you do your bracket first. 25 divided by 5 is 5 times 2 minus, okay, you can do the same at the same time because these are all the brackets, so you can actually do all the brackets at one go. If we are fast enough, okay, you can do that at the same time for all those things in the brackets, right? So 5 times 2, this one, we still have another bracket, so we will do the bracket first. We still have an inner bracket, right? Remember we say that the inner bracket, minus 2 plus 2. Okay, so once you solve everything within the inner brackets, then you can start to operate your outer brackets. 5 times 2 is 10, minus 2 plus 2 is 0. So this will give you 10. Okay, so it's important to remember the order operations. So this is what we call the order operations. So to recap, okay, so do anything that's inside the brackets. Then after that, move on to do multiplication, division. And the last step is to do all the addition and subtraction here. Okay, so now, okay, so okay, we can also use your calculators to check answers. So at the beginning, if you are not sure if your adding, subtraction, multiplication, and division is of negative numbers, okay, you're still unsure, you can actually make use of your calculators to find the answers here. Okay, so you can try using your calculators to punch in all the numbers that's shown here. Like for example, here we have this minus 3 times 7 minus square root 4 plus 5 squared. Okay, so having said that, the calculators actually has a hidden function whereby they will, okay, operates based on the order operations here. Okay, so if you key in your calculators, okay, your calculator is smart enough to help you, okay, to operate the expression based on the order of operations. Okay, if you don't believe, you can try. Okay, you can try it yourself, pressing this number that is shown here. Okay, yeah, you can try it on your own. Okay, you will get the answers too. Okay, basically your calculators will help you solve this. Okay, with the use of the order operation here. Okay, so you want you can try on exercise 4. Okay, so we can try using your calculators and okay, try pressing the calculators and see whether you can get the answers for part A and part B here. Anyone has an answer for this? Okay, yes. Part A. So if you press your calculator, right? Yes, you'll get the answers minus 3.98 for part A. How about part B? Anyone? Anyone has the answer for part B? Okay, you all can try out yourself. The answers is 2.11. Okay, answers for part A is minus 3.98. Answers for part B is 2.11. Okay, of course, this is correct to two decimal place. Okay, it is minus 3.29 because you do notice that there's a minus here. Okay, when you have a negative number multiply positive numbers, divide by positive numbers, you should get the negative numbers. Okay, so double check your answers again. Okay, so you can check on your calculators whether you put in the negative sign. Okay, it will be a negative number for part A. Okay, so you all try and let me know. So I'll move on to the next part. Okay, example 5. Okay, so here we have a mathematical competitions. A correct answer is awarded 4 marks, but the wrong answer will be given a penalty of negative 1 mark here. So which means, okay, the penalty of negative 1 means 1 mark will be deducted. No answers will be given 0. Okay, so here, Rachel participated in the max competitions and she was given 20 questions and she answers 11 questions correctly, 6 questions wrongly. So how many marks did she score? Okay, so the solution here is, okay, so because for 4 correct answers, right? Sorry, for 11 correct answers, she will score 4 marks, so it's 4 times 11. And for the 6th question that she answered wrongly, she will be deducted 1 mark. So it's minus 1 times 6. And she didn't answer 3 questions. Okay, so she will be awarded 0 marks here. Okay, so if you solve this, you will get 38 marks. Okay, so remember the order operations, we need to do the multiplication first, right? So you are supposed to multiply, do all the multiply first, and then followed by all the addition. Okay, so remember your order operations, you will get answer as 38. Okay, let's try exercise 5. There are 30 questions in the mathematics assessment test. Correct answer is awarded 3 marks. Wrong answers will be awarded minus 1 mark. Okay, so if no answer is given, so 0 marks will be awarded. So it's similar to the format for your example 5. So can you find out what is the score for Peter? If he answers 16 questions correctly, 9 questions wrongly. Okay, so and which means you also need to determine how many questions he got wrong also, right? But okay, so here in the if you want to find out, it's actually 30 minus 16 minus 9, right? So out of the 30 questions, he didn't answer 5 questions. So can you form this equation here to solve? So what is the total mark score by Peter? So same thing, right? So we can say that because he answered 16 questions correctly. So he will get 4 marks, right? And for those questions that he answered wrongly, which is how many? 9, right? 9 times minus 1. Plus, okay, 5 questions that he did not answer and is awarded 0 marks here. Okay, so if it follows the order operations, we are supposed to solve all the multiplication first. This gives us 64. This one, minus 9. This one, 0. Okay, so you're supposed to solve all the multiplications, right? Hey, wait, sorry, it's 3 marks, not 4 marks, huh? Okay, it's supposed to 3 marks here. Okay, let me just cancel. This is 3. Sorry, yeah. This is 48. Okay, 48 marks. So it's supposed to be 48 plus minus 9 plus 0, correct? So this is supposed to be 48 minus 9, which gives you 39. Okay, so the total mark score is 39 marks here. Okay, so moving on to the last part, huh? So we can use your real numbers to solve all the reverse problems here. Okay, in other words, which is your word problems. So if you look at example 6, okay, Tanya owns a bakery and always sells her item at a discount after 7 p.m. The table shows the profit she makes for each item after 7 p.m. So after 7 p.m., you do notice that the profit that she has is actually negative value. Okay, which means what? Which means she is not making a profit. Instead, she suffered a loss. Okay, if she sells her items after 7 p.m. for the bread and the tarts. But for cookies, okay, she still makes some profit here, 120. Okay, so part A, you're supposed to explain why the value of minus 10 cents profit means for the sales of one bread. Okay, if you look at the solutions, okay, it's trying to tell you that she actually, instead of making profits, she actually make a 10-cent loss for each sale of the bread here. Okay, and part B, on a particular day, she sold 40 breads, 25 tarts, and 30 cookies after 7 p.m. So find her profit or loss for that period. Okay, so you know that out of the 3 items, okay, for bread and tarts, she's going to make a loss, but for cookies, she's going to make a profit here. Okay, so what you need to find here is, okay, profits is equals to, okay, she's selling 40 breads, okay, times minus 0.10 plus 25 tarts, right? 25 times a negative profit here, minus 0.30 plus 30 times 120. Okay, so remember we do all the multiplication first. So 40 times minus 0.1 give you minus 4. 25 times minus 0.3 give you minus 7.5. 30 times 120 give you 36. Okay, so after you've solved all the multiplications, you will subtract and add from left to right, which gives you the value 2450 here. Okay, so in the end, you still make a profit, for positive profit here. And part C, okay, if the price of the tart is 70 cents after 7 p.m., so find the cost of making one tart. Okay, the cost of making one tart costs 70 cents after 7 p.m. Okay, so you know that, okay, the tart, she actually make a loss of 30 cents here, correct? Okay, so if she sells it at 70 cents and including the loss, right? So it's $1. So in order to find the original cost, right, you need to plus back the 30 cents here, right? Okay, because you see, if you see in terms of the cost, so the profit is always the selling price minus the cost price, So the selling price is actually 70 cents, right? You minus away the cost price, which is $1, correct? So the profit is actually what you see here, negative 30 cents. Okay, so this is how you see. And part D, give a possible combination of the items you sold if you made 0 profits and sold at least 20 items. Okay, so one set here, okay, if you look at your solution here, it says that one set of no profits, is, okay, so how do you look at this? Okay, you know that, okay, she's going to earn 120 for selling a cookie. However, she's going to lose money if she sells breads and tarts, right? So one set of no profits here will be, okay, the case whereby she sells 3 breads, 3 tarts, 1 cookie. Okay, because when you look at the profit, it's 3 times negative 0.1 plus 3 times negative 0.3 plus 120. Okay, so in this case, you will earn nothing, a profit of 0, right? So this is the combination of having no profits. So which means, okay, if you want her to sell at least 20 items, okay, you do know that 3 plus 3 plus 1 is only 7 items. Okay, so it's not more than 20. So you have to find a multiple of this set of numbers in order to, okay, find a number that sells more than 20 items. So 7, what is the multiple of 7? 7, 14, 21, right? 21 is more than 20. Okay, so you need to multiply 3 to this set of the bread and tart and cookies here. So it will be 9 breads, 9 tarts, 3 cookies. Okay, but however, any other answers which is more than 20 and 0 profits can be also taken as a correct answer here. Okay, so this is only one of the possible answers. Okay, so for the last exercise 6, okay, let me run through also. So a confectionery carried out a sales promotions for some of its new product at discount in order to promote the new products and increase the sales. The following table shows the profit that the confectionery made for each item sold during the sales promotions. Okay, so from the table you can see that, okay, he's actually making a profit by selling the cheesecake, mousse cake, lemon pie, no profit, it's a break off. Okay, no profit, 0. And for durian cookies, okay, he will make a loss. Okay, a negative profit means a loss. So part A, explain what's the value of $0 profit means for the sales of 1 lemon pie. So basically, it just means that, right? The lemon pie is sold at a price. That is the same as its cost price. So this is called break even, right? So we do not earn anything here. Okay, so exactly same as the cost price here. And part B. During the sales, the confectionery sold 180 durian cookies, 20 mousse cookies, 50 cheesecake, and also 48 lemon pies. So find the profit or loss during the sales period. Okay, so here, as you can see from the example earlier, so we use the numbers that the confectionery sold, 180 durians, right, times the profit here. Okay, plus 20 times the profit accordingly, plus 50 times the profit, plus 48 times the profit here. Okay, so the profit will be the sum of all the things that he sells. So 180 durian, and each durian make a loss of 40 cents, plus your 20 mousse cake, the profit is 60 cents, and then your cheesecake, 80 cents, and then lastly your lemon tarts, which is, okay, 0, right? So when you add this, okay, remember you need to multiply before you add. So this will be minus 72 plus $12 plus $40, which gives you, okay, a profit of negative $20. Okay, so for part C, if the promotional price of the durian cookies is 120, find the cost of making 1 durian cookies. Okay, so just now we already see how to find the cost price, right? Okay, the cost price will be equals to, okay, so it's sold at 120. No, yes, it's sold at 120. But however, okay, if you make a loss of 40 cents, okay, so you are supposed to add that 40 cents, right? Because just now I showed you earlier, right? So your cost price is equals to your, okay, the selling price plus the amount that you lose, right? Earlier on. Okay, so this part here we did mention here. Okay, if you want to find the loss, okay, if you use the cost price minus the selling price minus the cost price, you'll get the profit that you get, which is a negative value here. Okay, so for part D, the last part, based on the respective numbers of items sold in part B, find the minimum additional number of moves cake that the confectionery needs to sell in order not to make any loss. Okay, so we are looking at moves cake. So we look at the profit that she earns for selling the moves cake, which is 60 cents here. Okay, so based on what you see in part B, okay, so here, let's do, okay, so now the mousse cake sold is 20, right? So, but now if he sells the mousse cake at 20, he will make a loss of negative $20, correct? So here, a bit of guess and check here now, huh? So when you look at 60 cents, okay, so how much you need to compensate for that negative $20, right? $20 divided by 0.6. So it means that you have to sell about 33 mousse cake here. $20 divided by 60 cents is about 33. So when you have additional 33 mousse cake here, so how much will you earn here? Okay, if you have 33 mousse cake, you have 33 times 0.60. This is equals to 1980. Okay, this is not enough to compensate your negative $20 here, right? It's not enough. We are still short for. So which means you have to increase to additional 34 mousse cake, right? And see, 34 times your 60 cents, okay, which is equals to $20.40. Okay, this is more than your $20, right? So you can compensate the loss that you make in part B. Okay, so you have to sell 34 cakes here. Okay, so this is the answer, 34. Okay, anyone has questions? Okay, so if not, then okay, I'll pass it on to Teacher Wei Lun, where he will introduce to you guys more about algebra here.
Yeah, thanks, Teacher Chang Hing. Yeah, so let's go through now in terms of the algebra chapter. So actually, I'll be sharing my screen, right? So you all should be able to see my screen now. Okay, so as you all will know, actually, algebra is not something that is new to everybody here, right? In fact, you all have learned it in primary 6 as one of the chapters. So what we are going to do now is that we are going to recap a bit on that, plus also go through some of the new concepts that will help you all when you all go to secondary school. One thing to note also is that you see algebra, it becomes a very important topic in secondary school. In fact, I would say that algebra is like the most important topic because once you can master that, actually throughout Sec 1, Sec 2, Sec 3, Sec 4, and even after that, when you go to post-secondary and university, you will continue to use algebra. It's also quite different from what you all have been doing in primary school. So in primary school, you will see that actually a lot of times we look at models, we look at power codes, we look at problem solving strategies, correct? But right now, you will see a lot more of the questions are solved going to be using algebra method. So because of that, actually, it also means that sometimes if you feel that, maybe at the primary school level, you never really do quite well in terms of some of the problem sums, it may change in secondary school because we also see a lot of students who even though they didn't really do well in primary school, it's because they are not very familiar with certain problem solving strategies. But when it comes to secondary school and they're quite good at algebra, they actually end up doing quite well at mathematics because mathematics becomes more algebra focused. Okay, so that's also something that I wanted to highlight to you all. Okay, so with that, right, let's start to go through over here, right? So in terms of the key parts here, this particular first page, right? Okay, on 2A. So just a few things to note. The idea here is that this is not really new to all of you. You all have seen it in primary school. adding, subtracting, multiplying, and dividing of algebra, they will all also follow similar principles to how we do it for numbers, right? So what does it mean? So for example, if you look at something like that, where we have addition, we have 1 plus 2, right? So let's say you have this number 1 plus 2. 1 plus 2 is going to be the same as 2 plus 1, right? It means the same thing. And they both give you 3, right? So the idea is that even though the order is different, it doesn't matter. The outcome is still the same. So given the same logic, if you look at it in terms of algebra, be it whether you do x plus y or y plus x, it will also give you the same answer, right? So that's how we think about it, okay? So that's the first part for addition. The next part is when we come to subtraction. Okay, so subtraction, right, guys, I can ask you a question now. So let's say if we do 4 minus 3 versus 3 minus 4, will they give you the same answer? You all can type in the chat. Is it yes or no? So do they give you the same answer? 4 minus 3 and 3 minus 4. Very good. So like what Rishi, Isabel, and Riyao have mentioned, they do not give you the same answer, right? So unlike addition, you can see addition, they give you the same answer. But subtraction, they don't, right? So subtraction, 4 minus 3 is 1. 3 minus 4 is what you all just learned just now from teacher Chang Hing, right? So 3 minus 4 will give you, maybe test you all on your negative numbers, right? So what is 3 minus 4? So you all just learned negative numbers just now, right? So 3 minus 4 equals to what? Yeah, very good, right? So -1, okay? So Safwan, Josh, Rishi, Yu Yao, all correct. So you all can see the numbers are different. And what's the takeaway here? The takeaway here is that when you're minusing, the order matters, right? So whether you start with 4 first, followed by 3, or you start with 3 followed by 4, it will give you a different answer. So similarly for algebra, it's the same thing. So what you all need to recognize here, guys, is if you have two, what we call as algebra terms, if you have A minus B is not going to be the same as B minus A, right? So that's what you all need to recognize, okay? Okay, finally, for multiplication and division is quite similar if I use a numbers equivalent to show you all. So for example, you all can see 3 times 4 is the same as 4 times 3, correct? So it doesn't matter even if you switch the orders around, it will still give you 12. So likewise for algebra, let's say you have two alphabets, which is P times Q. P times Q is going to be the same as Q times P, right? P times Q is going to be the same as Q times P. Just remember in secondary school, usually because the algebra terms that you use are quite a lot, usually you all can see what we can do is we can just combine it to be PQ. That means I don't need to write it as P times Q. I don't need P times Q like a bit low so, right? I put it as PQ, it is obvious that it's P multiplied by Q, right? So that is the form that you all can use when you all do workings for secondary school. Okay, so that's the other one. Finally, division C divided by D. The thing to note for C divided by D is that you can also put it in terms of a fraction, right? So this is how we also think about it in terms of expressing algebra terms. So you can either put it as C divided by D, or you can put it as C over D. C over D is a fraction, right? And C over D represents C divided by D. It means the same thing, okay? So these are the things that, as you go into secondary algebra math, when you do addition, subtraction, multiplication, and division, these are some of the things that you need to take note. Okay, I've not really gone again into what is algebra and everything, because all of you would have done that already, because that is one chapter in P6. So I won't go through that again in detail, but to recap, so essentially you can think of it as algebra is a lot like numbers, right? It's just that instead of numbers, you now have alphabets, right? And the alphabets represent something, right? And what does it represent? Later, we'll go through some problem sums to recap on that, okay? So these are the basic notation. Next, in terms of what we call as index notation. So in Set 1, you will start to learn this thing called index notation. Index notation just refers to a form like that. So you will see something like that, 8 to the power of 4. 8 to the power of 4. This number here is what we call as the power, right? Is what we call as the power. So what does the power tell us? The power will tell us the number of times we are multiplying this number by itself, okay? It will tell us the number of times we are multiplying the number by itself. So let's say you see 4 here, it will mean that we're just doing 8 times 8 times 8 times 8, right? So it's multiplying by itself 4 times. So this one, again, you are not unfamiliar with it, because in primary school, you all actually have done square and you all have done cube, correct? So 8 square is 64, 8 cube is 64 times 8, right? And that is 512, correct? So you're not unfamiliar with that. But what you all need to recognize is when you come to secondary school, the power can go higher. So it may not be 2 or 3, it can be 4, it can even be 5, right? And when you go to Sec 3, Sec 4, when it gets more complicated, the powers can also get way higher. But this is all what we talk about when we think about index notation. It is telling you how many times do you multiply the number by itself, right? And what you do for numbers, you can also do for algebra. So you see here, p times p times p times p, that is the same as p to the power of 4. So when you see something like p to the power of 4, it means you are multiplying p by itself 4 times. Okay, 4 times. And a very important misconception is that a lot of students, when they first start, right, they like to think of p to the power of 4 as going to be the same as 4 times p. But this is wrong. So guys, this one you all need to cross out, right? You all need to do a big cross here. A lot of students have this misconception. And why are they different? The thing to note is when you have p to the power of 4, p to the power of 4 is p times p times p times p. Whereas 4p is p plus p plus p plus p. So take note, guys, very different. You see? So this one, p4 is this, okay? Whereas 4p is this, okay? They refer to two different things. So from the get-go, be very clear, right? And avoid making this mistake, okay? So a lot of your, seniors, they will make this mistake. So don't make that mistake, okay? So that's the front part on the notations. Now we go to the next part on algebraic expression, right? So algebraic expression, a few things to note. What is an algebraic expression? Algebraic expression is just, you can think of it as a string of terms. Something like that, you see? All these are expressions, right? All these are expressions. You have a string of terms. There could be alphabets inside, there can be numbers inside. So that's how we think about it. That is an algebraic expression. So again, as part of this algebraic expression, there are some things that you need to recognize. So for example, when you see this 5x, so even in primary school, you have seen it before, but you may not have been so exposed to the name for that number in front of the x term, right? So when you see this number in front of the alphabet, the number here is what we call as the coefficient, right? So it's just something that is important for you to know, because this will be a term that we would use more of, right, when you go to secondary school. The number in front of the algebra term is what we call as the coefficient. Okay, so that's another thing for y'all to take note. Then apart from that, it's just a matter of looking at expressions only, right? And here, another thing to recognize is what we call as linear versus non-linear expressions. Okay, linear versus non-linear expressions. Linear expressions and non-linear, generally when you go into Sec 1, you all can highlight the focus for Sec 1 will be on this part here, the linear expressions part. And what are linear expressions? Linear expressions, you can think of it as when you look at the expression, all the power on the terms are all to the power of 1. You see, they are all to the power of 1, right? And if it's to the power of 1, then these are what we call as linear expressions, like linear. What are non-linear? Non-linear is where you see there are different powers that starts to come out. There's not 1. So if I highlight for you here, you can see there's going to be a square, there can be a cube. Then you may ask me, but teacher, this one also don't have any power, right? So this one you won't learn yet. So this one is a bit more complicated. But what you all need to recognize, okay, again, guys, this one just for your good to know for now. This is actually what we call as x to the power of -1. But you don't need to go there yet. So don't worry too much about it, right? Because I know today is the very first time you learn negative number. Then you mean, wow, teacher, now also got negative power. But remember, this one is a bit complicated. You don't need to go there. But I'm just highlighting it to show you why these are all non-linear. So non-linear is so long as you have powers that are not 1, that creates a non-linear expression. But for Sec 1, you can focus on this part, okay? Sec 1, just focus on this, okay? So Sec 1, it will still start off pretty standard, right? But towards the later part, right, that's where you will start to learn some of these x squared terms and everything. But in the earlier part of Sec 1, it will be more of this when you start to just get used to it first, okay? But later on, right, and also depends on the school. So some of you who may be going to IP and everything, you also may be introduced to this earlier on. Okay, but generally, this is the thing to take note. Okay, and then now let's look at some expressions and some calculation on the next page. Okay, so here, right, is four things that we will do, right? Which is then we will try to rewrite the following as what we call as algebraic expressions. So the way to think of it is that you can think of it as we are actually translating from English to math. That's how we think about it, right? For this kind of question. So they will tell you something like sum. So if you go through, right, sum of 3x and 6y. Sum, if we translate to math, it refers to a plus. So if it's sum of 3x and 6y, it just means 3x plus 6y. Okay? So guys, I want to ask you all a question now, right? Why is the answer not 3x plus 6y, right? Why is it not just 9xy? So as some of you wondered, so is it 3x plus 6y combined together? I just combine all the numbers and alphabet together, and then it becomes 9xy. Why is that not correct? Can you all type in the chat? Yeah, very good. So some of you are very fast, right? Like what Chloe has mentioned. These are different variables, exactly, right? You all look at it here, right? This is an x, this is a y. You can even think of it as, it's like, yeah, like what Safwan also mentioned, x and y are different, okay? It's like saying 3 apples and 6 orange. So 3 apples and 6 orange, you can think of it when we try to add them together, or when we try to minus, especially when we do add and minus, when you do add and minus, it must always be apples and apples. So you all may want to take that down, right? So apples and apples. So in this case, because it's not apples and apples, we cannot combine them together, right? And what Rishi also mentioned, which is very good. When do you get 9xy, right? And in fact, you will never get 9xy, right? But what you can get is when you can combine them together is, let's say you do 3x times 6y. 3x times 6y would then give you 18xy. So the only time when you can combine them together is when you are doing multiply or divide. Okay, so take note. So if you do multiply or divide, you can combine. But if you are doing minus or add, then it must be apples and apples. That means if they are not apples and apples, you cannot add or minus them. Okay, so be very clear. Okay, yeah. So now that's why you see 3x and 6y, we can add it only as 3x plus 6. We cannot combine. Similarly, subtract 7p from 3q. So what I'll do is I'll just take 3q minus 7p. Okay. C and D, your C is product and divide. So product and divide, we don't need to care about apples and apples or apples and orange. Product and divide, we can just combine together. It's okay. Okay. So when we do product means to multiply, right? So product is another word for it is multiply. So when we multiply 2x and y, 2x times y will just give us 2xy. So guys, remember again, I don't need to put like that, okay? I don't need to put like that. So in secondary school, actually, you can just combine them as 2xy. Is understood that is multiplying, okay? Finally, 8ab over 3c. So again, you can see we can put it like a fraction form where the numerator is 8ab and the denominator is 3c. Okay, so this is what we mean by converting from English to math. So why don't you all try, right? So you all take a look at this. Just do a quick try and put it in the chat, and then after that we'll go through, right? So exercise 1, right? So write the A, B, C, and D in the form of algebraic expression, and then you all can type in the chat. Okay, so I give you all a couple of minutes. These are probably not that difficult. The only thing is that it's not difficult, but it's probably just tedious to type it out, correct? Because it's the alphabet and everything. Yeah. Okay, very good. So I see a lot of correct answers in the chat already. So let's go through together. Okay, so you all can see here number 1, right? So well done. I see a few correct answers already. So sum of 5x and 7y squared. So that will just be simply 5x plus 7y squared. And again, because it's adding, if it's not apples and apples, we cannot just combine together, right? We'll keep them separate, okay? So that's for A. Okay, now for B, subtract negative P from 3Q squared. So remember, what is the first number? The first number or first term is always whatever that comes after the word from. So in this case, we start with 3Q squared first. Then we will take 3Q squared minus... Okay, so guys, I ask you a question. If I just put it like that, 3Q squared minus P, is it correct? So if I tell you all the answer is 3Q squared minus P, is it correct? Yes or no? And why? Yeah, very good, right? So Iris, you're on the right track. So be very careful. This is a negative. Do you see? This is what teacher Changking was teaching you all just now, right? It's a negative. So actually what happens here, right? It's a negative P. I'll put it within bracket like that. And we can further simplify this because you all remember just now, we said minus give us a plus, right? So actually the correct answer is 3Q squared plus P. So again, a lot of students, when you first do things like that, you all will forget there's a minus in front. So don't forget, you see, there's a reason why there's a minus. This is what we call as negative P, right? And the takeaway here, guys, is just now you all learned about negative numbers, right? It's also possible to have negative algebraic terms, okay? And to take note, we would usually not put it as minus. I would convert to a plus, right? That will be the final simplified form for you to get this correct. Okay, can so that's for B. Okay, now for C, product of 9x squared and negative 4y. So when you do 9x squared times negative 4y, right, guys, the easy way to look at it is we just take the number combined by the number. So that will give us negative 36. Then x squared and y will just be combined together, right? So that's how we can do that. So that's negative 36 x squared y. And then finally, D, 24a squared b divided by 6ac. Okay, so this is like a fraction form. So guys, ask you all a question. Do you all think there's anything more that I need to do here for this part? Is there something that I can do? I didn't really go through this just now, but I give you all a hint. It's based on what you all understand from fractions. Is there anything more that I should do here? You all can type in the chat. What do I need to do for this last question? 24a squared b over 6ac. What more do I need to do? Yep, very good, right? We need to simplify, like what Divya mentioned, okay? Exactly. So this part, right, actually, it depends on whether you are familiar with algebra fully already. The idea is the 24 and the 6 is quite easy to simplify, right? So this one you can simplify, divide by 6. Here you divide by 6, it gives you a 4, okay? The B and the C you all can keep. But I know your questions in your mind is you have the A square and the A, right? How to simplify, right? The way you can do it, like what Chloe mentioned, you can simply cancel out here. So I can show you a simple way to think about it. So A square over A is the same as, A square is the same as what? A times A, right? And then you divide by A. So if you cancel, actually we are just left with one A term at the top. So that's an easy way for you to remember that for a start, okay? So that's how we look at it. Oh, so good point, so good try, but there's no more 6 at the bottom, okay? Because remember, the top part I divide by 6. The bottom part I also divide by 6. So the bottom part already becomes 1. So my final answer will just be this, 4ab over c, right? So that's it, okay? Yeah, so just take note, just always check whether you can simplify, whether you can reduce to the simplest form, okay? Okay? Any questions on this, right? So this is algebraic expressions, okay? The next part that I'm going to go on to, right, is really in terms of simplifying more things, right? More things. So what are these things? You can see over here, right? The terms that's given, right? So if we look at this, let's say we have something like this first part, a times 3. So just remember, a times a, we can put it as index notation form. So index notation form, we can put it as a squared. A squared, the power just tells you we are doing a times a, correct? And then times 3, again, I can just combine them together to give you 3a squared. So in short, you see, guys, I remove all the multiplication sign, right? And then the a times a, I collapse it to become a squared, so that it's not so loso, right? So it's very elegantly combined into one single group of terms itself, okay? So that's for A. That's how we simplify this. For B, you can see 4C over 2, right? So 4C over 2, same thing. You can just divide like that, and then you just get 2C. Okay, 5H over 10K is quite similar to how I've done it just now. Again, you can put it as a fraction and reduce to the simplest form. Okay, and then D, I think D is more of the same, so I won't really need to go through that again. E, I want to go through a bit. So E is where you'll see some of the things that we mentioned just now about number operations come in again, right? So guys, you can see over here, number operations, we always start with divide and times followed by plus and minus. So in this case, given that it's just divide and times, I will just go from left then to the right, right? So I just go from left to right. So what I do is, you see, I just start with this part first. So it's 7t divided by 15. Then I do times 3t. So guys, in case you all are not as comfortable with this, just remember this is exactly how it would work for fractions also, right? Last time when you all did whole numbers times fraction, right? It's a similar concept. So what I can do is I can just take this number, or rather this term, 3t multiplied by 7t, that will give me 21t squared over 15. And then I can simplify to reduce to the simplest form. I can divide by 3 at the bottom and 3 at the top. So that will give me 7t squared over 5. So you can see what logic you apply when you do numbers is the same logic that you also apply for algebra. Okay. Finally, F, just remember again, number of operations. The plus, we will do it at the very last. So I will do this divide first, okay, followed by this. So I have s over 6 plus 2s over 3. So guys, again, you all can see over here, even though it's just algebra, same concept. If it's a fraction, I will just make them the same denominator. So here I'll just times 2 times 2. So I'll get 4s over 6 so that I can combine them into 1, which is 5s over 6, right? And that's it, right? So again, these are things that, in fact, I would say from P6, you have already gained that familiarity. So it's just doing drills on this to make sure that you are good with them. So let's try, so let's take a look at these together, right? And then you all can tell me the answer. I think some of you have already started to work through them, right? So perhaps for those of you who are already done, let's start to work through together, okay? So question A, what is the answer for A? You all can type in the chat. 5 times B times B. What does it give you? Okay, you all can type in the chat. Very good, right? So I see correct answers already. Okay, A, the answer is 5B squared, exactly, right? So well done, Iris and Safwan. Remember, don't write it as 5BB, we don't write 5BB, okay? We write it as 5B squared, right? So some of you may even it'd be more mind-boggling, right? You see, let's say you have something like that, is it then you write it as 5BBB? No, you won't do that, right? We won't do that. So we would have to put it as what we call as index notation. So you can see it's more efficient and it's cleaner that way. Okay, so it's 5B squared. Okay, 5B squared. You won't write it as this, remember, you won't write it as this, but you will write it like that. Okay, what about B, right? B, 18D divided by 3 is equals to what? Very good, right? So 18D divided by 3 is 18 divided by 3, that is 6. So you have 6D. Okay. Next, C, we have 8Y divided by 24K. Okay, 8Y divided by 24K. So again, guys, you all can think of it as it's the same as this, right? And then you can reduce to the simplest form, right? You can divide by 8 throughout, right? So good job for those in the chat. So this will be Y over 3K, right? Y over 3K, okay? Then for D, right? So D, 4P times 6Q times 2P. What would this give you? 4P times 6Q times 2P. It will just give you 4 times 6 times 2. That will be 48P square Q, right? 48P square Q. Okay, very good. Okay. And then finally for E is 7T, okay, divided by 15, okay, times 3T. Okay, so how do we do this particular question here? So this one here, you all can see, right? So for this particular part here, we have 7T divided by 15 times 3T. So that will give us 21T squared over 15. And remember, you can simplify further. So this is divided by 3, that's 7. So it's 7t squared. 15 divided by 3, that's 5. So that will be the answer for E, right? So it's 7t squared over 5. Okay? Okay, for F, maybe y'all can try and let me know what's your answer, right? So t divided by 3 plus 2t over 6. What will you get? Maybe y'all can try a bit, and once you have your answer, you can plonk it into the chat. Very good, right? So, okay, I see some answers, but so far not correct yet. So far I haven't gotten the correct answer yet. Maybe for those who have typed in the chat, you can try again. Okay, well done. Yeah, I see some correct answers already from Amelia, Chloe, right? Okay, so y'all take a look. So correct, right? Well done. So I see a few more answers that are correct. So t divided by 3 is the same as t over 3, 2t over 6. Okay, and then just remember, we can combine them together, right? So the way to combine, you can actually see here 2t over 6 straight away. You can actually reduce to the simplest form. That is actually t over 3. You see, 2t over 6 is the same as t over 3. And then when you plus the t over 3 here, that will give us 2t over 3, right? So the correct answer is 2t over 3, okay? Yeah, so guys, also as a good practice, you will see like 4t over 6. You can also try to simplify to the simplest form, okay? Why does it help? Because in secondary school, you realize at least for now, it's still the building block. But over time, the algebraic expression will get more and more complicated. And things like, by making it simplest form as far as possible, it will help you when you do more complicated calculations later. Okay, when you do more complicated calculations. Okay, so this one maybe for those, some of you wrote t squared over 9, you may want to relook it a bit. They won't be t squared because we are not multiplying. You see, t squared is what? T squared is t times t. But in this case, it's not times, it's plus. So we will never have a t squared. Okay, so just take note, guys. Here, you see, t squared is t times t, whereas 2t is t plus t, t plus t. Okay, so take note of that. Why is it 3 and not 6? Is it? Okay, so the idea here is that because you can see I'm combining them into the same fraction with the same denominator of 3. So you see here I have t over 3 plus 2t over 6, right? The 2t over 6, I see I can actually reduce to the simplest form already. I can divide by 2 here, I divide by 2 here, that's how I get t over 3. So I get t over 3 here. Here also I have t over 3. When I combine together, I will get 2t over 3. Okay, can Okay, so guys, we may overrun a bit because there were a couple of questions and we wanted to work through them just now. But no worries, for those of you who may need to drop off earlier, you can. But we will likely just need about 15 or so minutes, 15 to 20 minutes. So if you can stay, it will be great. Then we can just work through the rest of the questions. But if you can't and you have other commitment, it's okay for you to drop off. But strongly encourage you just stay for then we can just finish up. It should take no more than about 20 more minutes. Okay, yeah. Okay, so this is for this part. Okay, next, evaluation of algebraic expression. So this one is fairly simple. So we have revised a bit on how do we combine expressions together. Algebraic expressions evaluation, in fact, if we just go to an example, so it's very easy for you to see, it's just substituting the alphabet with numbers only. So you see here, what's going to happen in the question is they will tell you 4a plus 5b, then they give you the value of a and b. So they say, oh, a is negative 2, b is 4. What would be the answer? So all you need to do is just substitute only. So you see a is negative 2. I will just put it as 4 times negative 2 plus 5 times 4. But you all just need to recap on how you all do negative numbers evaluation, right? So you see 4 times negative 2 is negative 8. So negative 8 plus 20 is 12. But other than that, the mechanics is always the same, right? Just replace the alphabet with the relevant number and then calculate. That's all, right? That is what requires evaluation. In fact, even in P6, there were also questions that were already like that already. So it's not new to you. The only difference is you probably just have not seen negative numbers at that time. Okay, so let's work through together, shall we? So if you all look at this particular question set, you all can type out your answer, right? So for those of you, I think you all have worked ahead, right? You all can tell me what is the answers that you all have over here, right? So this one here, question A. Okay, question A, okay. So this one, okay, there's a bit of a typo, so you all can see this one and this one is not needed, it's duplicated. So there's only 4 questions only, okay, these 4 questions, So you all can type in the chat. So A is what? So A is equals to 2, B is equals to 4, right? Very good, right? So I see some correct answers in the chat. So that's 3 times 2 minus 7 times 4, right? And just replacing the A term with 2 and the B term with 4. Then you will get 6 minus 28. 6 minus 28, that's where like what you all just learned becomes very important, okay? So 6 minus 28 will give you a negative number, which is negative 22. Okay, so that's for A. Now for B, same thing, right? So we just need to replace. So we have 3 times 1/3 minus 7 times half. Okay, so 3 times 1/3 is 1 minus 7 over 2. Okay, so this one is actually fractions. So 1 is the same as 2 over 2 minus 7 over 2. If it's easier for you because now you have fractions and negative number, you can just combine it together like that. So it's easier for you to see. So this is the same as negative 5 over 2, which is equals to negative 2.5, right? Negative 2.5. Okay, so that's the answer for part B. Okay, part C, 3 times 2 minus 7 times negative 1, because A is 2 in this case and B is negative 1, right? So then what we have is we have 6 minus 7. So this is what you all just learned, right? So minus should give you a plus. So that will give me 13. Okay. Okay, finally for D. D you all want to try? For those of you who have tried, can you tell me what's your answer? D is a bit tricky also because it involves fraction and negative numbers. Those of you who have tried, you all can type in the chat. What do you all get for D when you all calculated this? You may feel a bit stuck if you are not as familiar with negative fraction. So I will also go through. But anybody manage to try and see whether you can get the correct answer? Okay, so this one, the way to look at it is like that. So you all can see over here, right? Okay, very good job. So YN, Kaden, your answers are all correct. So that's good. So this one is that you can see we have 3 times negative 1 over 6 minus 7 times negative 2. So quite a lot of things going on, right? A lot of negative numbers, a lot of fraction. So here, 3 times negative 1 over 6, that is the same as negative 3 over 6. And here, minus 7 times negative 2. So guys, what you all need to take note is when you have this negative 7 and negative 2, negative times negative will give you a positive. That's why what will happen here is it will become a positive 14. Okay? So here, minus 3 over 6, if we reduce to the simplest form, that is minus half. So minus half plus 14. This is what just now the tip that we taught you all, right? You all can reverse the order also. So it's the same as 14 minus half actually. So 14 minus half is just 13.5. Right? So that's the answer for this question. Okay. So the part here that is a bit more new to you is this portion, where you all can see here when you have a minus 2 times the minus 7, it will actually give you a positive 14. But don't worry too much about that. That is just a dip your toes in the water. So in secondary 1, you will start to see a lot more of that, where you have this minus becomes a plus kind of questions. Okay? Okay, so that's the answer for D. Right? So D, the answer is 13.5. Okay? Okay. Now, right, so everybody can look at this example, the next question, okay? So the next question here is this one, right? I want you all to just try this example, exercise 4, and then tell me what's your answer, okay? So for example 4, you can see is exactly what we did just now, right? So all we are doing is just plonking in the numbers. So I won't go through in as much detail. You just see that actually the terms are more complicated, right? A lot more terms, a lot more things going on. But it's again just putting in all the numbers. So you can see a few things to note, right? So we have minus B. minus b. So in this case, b itself is negative 3. That's why I have minus 3 plus square root, right? And then b is minus 3 squared minus 4 times negative 2 times 5 over 2 times negative 2. Right, so the hard part is now there are just a lot more negative signs in the picture. The thing for you to take note step by step is just remember when you have a minus and a minus, it will just becomes a plus. That's why you can see here, it just becomes a positive. Okay? Here, minus 3 squared, remember minus 3 squared is the same as minus 3 times minus 3. That will give you a 9. That's why we have a 9 here. Okay? And then this particular portion, okay, just take note, this part can be a bit more tricky. 4 times 5 times negative 2, that is the same as negative 40, right? Because it's 4 times negative 2, that's negative 8. Negative 8 times 5 is negative 40. So guys, in case you're wondering, then why negative 40 becomes a plus here? It's because what you all need to recognize is there's another minus here, you see? Another minus here. So what it gives you actually is the same as saying 9 minus 40. So that will give you 9 plus 40, right? 9 plus 40, okay? And then you have square root 49. So square root 49, I think you all have seen, right? Square root 49 means what number multiplied by itself will give you 49. So that's 7, right? And then we can calculate from there. Okay, so this is it's not like overly difficult, but it's just there's a lot more minus sign for you to work with. So perhaps for those of you who have done this, are you all able to tell me what's your answer for exercise 4? Exercise 4 will then require some of those technique, a bit quite like how we did for the question above, right? So you all can try, right? Exercise 4. So after exercise 4, we just do a quick wrap up with the last practice questions, and then we are done already. The last one is just about 3 questions only, okay? Anybody can tell me what's your answer for question exercise 4? This one. Okay, once you all have it, you all can type it in the chat. Okay, so take another 10 seconds or so, okay, before you all type in the chat. Okay. So some of you are a bit stuck, right? Okay, so no worry. Let's go through together for this particular question. So here, right, you all can see we have y is equals to a times b to the power of x minus 1. So it sounds a bit intimidating, right? A bit scary, right? Then how come even the power got alphabet one? But don't worry about that. The idea is whatever that you see in terms of the numbers here, you just replace the alphabet with the numbers will do, right? So let's do it step by step. So you all see a is negative 2. That's why I will swap it with negative 2. B they say is negative 5. So I'll just put that as negative 5. X is what? X is 3. X is 3, right? So X is 3, I will put here as 3 minus 1. The small numbers is the power. This is the power, okay? Next, when I further simplify, I will then get negative 2 times negative 5. The small power, because it's 3 minus 1, it just give me 2. Okay, it will just give me 2. So this is what you all need to recognize. So guys, I want to ask you a question. What does this give you? What does negative 5 square give you? Can you all type in the chat? Okay, some of you got the correct answer already. Well done. Okay, but break up by parts first. What does this give you? It's a bit tricky question. So some of you almost correct, but part of it not so correct. Okay, so some of you told me, right, this part is negative 25. Negative 25. So guys, I want to tell you all, right, so there are two answers. You tell me which one is correct. Is it negative 25 or is it 25? You all can all type in the chat. What do you all think? So negative 5 square, is it 25 or is it negative 25? And why I ask that, I can tell you all, like your seniors, Sec 3, Sec 4, they still make this mistake, Same thing, right? So from the get-go, it's very good that if you get it correct, right, then you will not get it wrong anymore, right? So I see a mix of answers, right? Some say negative 25, some say 25. the correct answer is actually 25. Okay? So I know why some of you wrote negative, because you also saw the negative here, right? But remember back to the basics. What is negative 5 square? Negative 5 square means what? It means it is negative 5 multiplied by negative 5. You see? So it's multiplied by itself. That's what it means when we say negative 5 square. Correct? And then now, guys, once you look at this, is it much clearer already? Because remember what teacher Chang-King taught just now? Negative times negative give you a positive, right? So negative times negative gives you a positive. So what you should be getting is 25. It's not negative 25. So you need to correct that misconception right from the get-go. Then you will have an edge over your other classmates already. Because a lot of people have this problem, right? But this is what you all need to recognize, okay? It's 25. So then we have negative 2 times 25. This part should be quite straightforward. So that is negative 50. Okay, so that's the answer for this question. So just remember, right? Just need to do step by step. Okay, put in the numbers and then calculate. Okay, any questions for this part? Okay, if not, I'm going to wrap up with the last 3 so-called problem sums questions, right? So that you all can get a sense of that. So let's go on to that, right? And then we are done for the day. So you all see for this set 2B, right? Essentially, the idea here is now that we learn algebraic expression, how do we use algebraic expressions in real life situations? In fact, even in PSLE, there were some questions that were already like that. So you all can already start to appreciate that. If we use this example, you all can see here, we have the price of a book is $4 more than a water bottle. And they say if the price of the book is X, express the price of the water bottle in terms of X. So you all can see, right? So in this case, the book is more expensive than the water bottle. So they want the water bottle, right? In fact, you all can still draw the model if you all want to visualize. But in secondary school, usually we don't need really. So you all can see the book is X. The water bottle is $4 less. So this must be X minus 4. Okay? So that's the idea behind that. For some of you, I know even in primary 6, you all had that problem where you find it a bit hard to reason like that. So if it's hard for you to reason, I would say at least for a start, when you want to try to get used to it, right? You can just replace this with any number. Just think of it as a number. So let's say if the price of the book was $10, what would have been the price of the water bottle? You would have been thinking, okay, that's pretty easy. I learned it in lower primary, right? So 10 minus 4 is 6. You see? Then straight away, you know it's 10 minus 4, right? So 10 minus 4, but now we are looking at it as X, not 10. That's why then the correct answer must be X minus 4. So that's a tip for you to get your brain warm up to this. Is just replace it with a number and you think how would you have answered it if it was a number. That will be a way for you to get used to that. Okay? Can? Yes, Ollie, the answer for the last part was negative 50. Yeah, right. Exercise 4 is negative 50. Okay? Can? Okay, so let's wrap up with the last few questions and then we are done. So here, mass of Henry is 6 kilograms more than Samantha. If Samantha is W, express mass of Henry in terms of W. Okay, you all can type in the chat. This should be pretty straightforward. So mass of Henry, okay, what would it be? I want to also take the chance to point out another common mistake. So a lot of you had the correct answer already, but got mistake. What's the mistake? So a lot of you wrote this, which is very well done. But do you all know what's the mistake? Do you all know what's the mistake? It's something that actually in PSLE also will have been a mistake. Okay, quite good. It's mass. So the units is kilogram. Correct. Right? So we put this in bracket and then we indicate it as kilogram. Right? Because W plus 6 can be what? W plus 6 can be apple, orange, not clear, right? So it's mass. That's why we put it as W plus 6 kilogram. Again, one key thing to note, secondary school presentation becomes a lot more important. Right? So if you don't write clearly or you present wrongly, you'll get marks minus, okay? Yeah. Okay, next, let's go on. Okay, this other part here, right, is let's take a look at it together, right? So we have this case whereby Linda is X years old, Ronnie, her brother, is 14 years older than her, okay? And then her mother is 3 times as old as Linda, their father is twice as old. So write down an expression. So similar concept. So you see Ronnie is 14 years older than Linda. So that's X plus 14 years old. Mother is 3X because it's 3 times Linda. So that's 3X. And then their father is 2 times as old as Ronnie. So 2 times as old as Ronnie, Ronnie is x plus 14. So 2 times as old is 2 times x plus 14. Again, we don't need the times. That's why I can put it as 2 times x plus 14 like that, right? Just within bracket, okay? So that will be for the father, okay? So again, this should be pretty straightforward, right? So let's take a look at exercise 2, okay? So you all can tell me your answer for part 1 and part 2. So part 1 is the number of apples in the carton. Number of apples in the carton, right? So what would be the answer here? Okay, very good, right? That's right, okay. So the correct answer for 1, I see quite a lot of correct answers already. So total apples is just P times Q, right? Because there's P cartons and Q apples in each carton, right? So that's P times Q, right? Exactly. Then good apples, because R are rotten. So total is PQ. R are rotten, so I just need to minus R. That's it. Okay? Yeah, so guys remember, so you all don't really need this. You don't need this. So in secondary school, it's understood when you write PQ, it's the same as P times Q. Correct. Because why? Because over time you realize it becomes very leceh if you have to keep writing like P times Q minus R. You see, your expression becomes very long. But you may tell me, but teacher, now still okay, right? But next time, you all will see very complicated. Once you reach later part of set 1, set 2, and so on, your algebraic expressions become very, very long. So you want to try to simplify it as much as possible. So things like that you don't really need in your final expression. I mean your final solution, final answer. Okay. Yeah. Okay. So that's the part to take note. So your final answer you can just put it as PQ minus R. Okay. No need times. Okay. Okay. Next, let's go on. The last one already. Right. So example 3. Okay. Example 3. So this is the actual problem sum. So let's go through this and your practice, and then we can wrap up for the day. Andy, Ben, and Charles shared a cost of a gift for their friend. Andy's share is twice that of Ben. Charles is a third, and let X be the amount of Ben's share. So guys, why we use this question is because you all realize actually in primary school, you all will have done this using like models, correct? You all will have done unitary model, right? And then do it, right? But in secondary school, no need really. And in fact, you shouldn't, right? You shouldn't be using models anymore. All we will do is the algebra concept, which is let X. So in this case, we are letting X be what Ben's share is. So once we know X is Ben's share, that's where we can then find Andy's share. So Andy is twice that of Ben, right? So twice that of Ben is 2 times X. So that's equals to 2X. Okay? Charles' share is a third of Andy. So if it's a third, that means it's 1/3 of 2X. So 1/3 of 2X, if you simplify, that will just be equals to 2X over 3, right? And then finally, part 3, if Ben pays $21, find the price of the gift. So the way to think about this is the price of the gift, right? If you look at it, is 21. But not price of the gift. I take that back. Sorry about that. Ben pays 21. So X is 21. X is 21 because X is what Ben paid. X is what Ben paid, correct? So once we know X is 21, how do we find the price of the gift? So what you all need to do here is we need to first find out what exactly is the price of the gift. So the price of the gift, there are 3 people who shared, right? There is Andy, there is Charles, and then there is Ben. So all I'm doing is I'm just adding them together. You see? I'm just adding the 3 together. And once you add all 3 together, you will then get the total price of the gift. Okay? And with that, given that we know it's 11/3 over X, and I know X is 21, I can just substitute this X with 21. And then I can solve from there. Okay? So that's all there is to this. And in fact, I would say even in primary 6, there were questions like that, but shorter. Right? They could just ask you a one-liner kind of question. This one is a bit longer, and it starts to get you to appreciate how we use algebra to solve questions. Okay? So with that, maybe we can try this, and then there will be a good wrap up for the day already. Maybe you all can just try this one. and tell me what's your answer, okay? You all can type in the chat. I give you all a couple of 1 or 2 minutes to go through, and then you all can let me know what's your answer. Okay, so this one is quite similar to one of the example questions, okay? Okay, very good, right? So I see some correct answers in the chat already. Okay, good. Yeah, so I see a lot of the first answer is all correct. Huh? So let's start to work through together. So we have Candy is Y years old, right? Her sister is 9 years older. The mother is 3 times as old. And their father is 4 years older. Okay? So expressed in terms of Y, their mother's age. So mother's age, right? So guys, just remember is 3 times of Candy. So 3 times of Candy, right? Like all of you have rightly mentioned in the chat, is just 3Y years old. So it's just 3 times Y only. That's it, right? 3 times Y. Okay, so that's all for the first one. So I think most of you got it right for the first one. Well done. So that's for part 1. Now for part 2, right? They want the difference between Candy's age and their father's age. So far, some good answers in the chat. The correct answer is 2Y plus 4. So for those of you who didn't get that, it may be a calculation error. So remember, to find the difference between Candy's age and the father's age, you should first find what is the father's age first. Correct? Because we don't know. The father's age is what? Is 4 years older than the mother, right? 4 years older than the mother, that means it's 3Y plus 4. Right? The father is 3Y plus 4. So what is the difference in the age? The difference in the age is just 3Y plus 4 minus Candy's age, which is Y. So when you minus like that, 3Y minus Y is 2Y, 2Y plus 4, right? So that's 2Y plus 4 years, right? So in this case, the correct answer is 2Y plus 4. Some of you wrote 2Y plus 13. 2Y plus 13 not correct. Maybe you can tell me how you got the 13, okay? So there may be a calculation error, right? So it should be 2Y plus 4 because this is the father's age and this is Candy's age. So we're just minusing from there, okay? Okay, final one. Final one is a bit harder. Anybody manage to get it? Average age. Average. Okay. Oh, third part. Okay. Good one from this student who clarified. But a bit tricky. So it's not 2Y plus 13 also. Although I know why you got 2Y plus 13. Okay. So you all can see average age of all the members. We need to first find the sister's age first. So sister's age we know is 9 years older than Candy. So that will just be Y plus 9. Okay. So now we got the age of everybody. Just remember, even though it's algebra, the concept of average is still the same. Concept of average means you take the total age of everybody. Okay, so average means you just take the total sum of all the age of all the family members. Then divide by total number of family members. Right? It's what you all learned last time, right? In primary school. It's just that. Even with algebra, it's the same thing. Correct? So total age is just Candy, Y, plus the mom 3Y, plus the dad 3Y plus 4, plus the sister Y plus 9. Right? So I will just add them all up first, like literally how I will do it, right? For numbers, but now it's for algebra. So once you add them up, you will get 8Y plus 13. Right? 8Y plus 13. Right? So 8Y plus 13, that is the total. If you were to find the average, it will just be, so this is the part that's a bit tricky. Some of you thought is 8Y plus 13 divided by 4, right? Because there are 4 people in total, right? Some of you thought that we should further simplify to give me 2Y plus 13. So this is the part that's wrong. So why is it wrong is because you see, you have 8Y divided by 4 is 2Y, correct? But you also have a 13. So don't forget, the 13 also needs to divide by 4. So the 13 also needs to divide by 4. So you cannot just have a 13 here because you did not consider this part. You see, you did not consider this part. Okay? So that's the thing to take note. So in fact, for this answer, you can just, it's okay for you to just leave it like that. We'll do 8y plus 3 over 4. That will be the answer already. There's no need for you to simplify further already. Oh, sorry, 8y plus 13. So sorry about that. 8y plus 13. I miss out transfer error. 8y plus 13. Okay? And that's it. Can? Okay. Any other questions? Okay, so if not, actually, that's the key part. So again, through today's workshop, right, it's more just to give you all a feel, right, of what is coming. In particular, I think once, like what you all have learned just now, negative numbers and everything is already a very good head start because once you go to school, at least you already know what is it. You know how to times, how to add, how to minus, and you also get a sense of how algebra is important as a topic and how you need it to solve problems going to secondary school. That means in secondary school, no more problem solving strategies, no more power code. It's really all algebra. So for those of you actually who feel like maybe math was not your strongest subject in primary school, you don't need to feel discouraged because there's a lot of cases of students, right? Who because they are pretty good at algebra, they actually end up doing very well. Like I've said before, so there are students whom I know who maybe like AL4, for math for PSLE. But when they go to Sec 1, they get A1 for math, right? And the reason why is because the algebra is very strong, right? So the tip here is build your good foundation in algebra and it will help you a lot, okay, for secondary school. Okay, so guys, the other questions, don't worry too much because what we are going to do later is that we will share this as a YouTube clip and we'll post it in our Telegram channel in terms of the link so that you at your own time, you can just refer to that and go through the answers at your own time. So don't worry about having to copy down everything now, okay? And I think all of you here should be also part of our Telegram group already, right? So you all can just access from there. We'll put the links there so that you all can just refer at your own time. So all these will be shared, including the videos and everything. Okay, Ken? Okay, so guys, that's the main thing for now. Are there any other questions or anything from anybody else? Exercise 2, is it? Okay. Exercise 2. Okay, Ken, I will just show a quick share of exercise 2 for Chloe. For the rest of you, you all can just take note of what we have posted in the chat regarding the Telegram communities, okay? Then you all can, if you all have not signed up yet, you all can just go inside. So Chloe, this is the one for exercise 2, okay? Yeah. For the rest of you, so actually that's the main part for today. Again, just want to take the chance since the posting is coming up, to wish everybody best of luck and hope that you all manage to go to where you all wanted to go for your schools. And just remember, secondary school is a new chapter ahead, right? So even for math, right? So think of it as a new chapter altogether. Just give it your best shot and start with a strong foundation, and you should work out fine. Okay. Can so with that, if there's nothing else, okay, if there's nothing else, then that's all for now, right? So wish everybody a good week ahead. And if you are attending our other Jumpstart sessions, do continue to keep a lookout for all the other events because we will have a lot more events in the year. And it's not just for primary 6 and primary school. We also have secondary related webinars and all. So do keep a lookout for that. And definitely like what we put in the chat, also do join our secondary Telegram channel because a lot of you are in our primary one, right? But now you go to secondary school already, you can join a secondary where we'll also share resources and everything. Okay, Can. So if nothing else, then that's all for now. Thanks very much everybody for joining us today, and thanks Teacher Chang Hing as well. So with that, we'll see you all around, right? Have a good rest and we'll see you soon. Bye everybody.